Yes, good evening, all of you. So no holiday because we need to complete the syllabus. Tertiary winding is placed on the same core. You can place any side because on the limb, three limbs we have and two limbs, empty limbs. So there you can place or on the yoke, horizontal part, anywhere you can place on the same core. Yes, interest current that will come in the switching transient. So mostly by tomorrow I will take that up. See the question. Yes, Shubham. For same turns, voltage E2 also same. If number of turns is same on both the sides, EMF also same. Okay, right. See the question. Consider the following statements concerning the utility of mesh connected tertiary winding. Mesh connected means what? Delta connected. Mesh connected, nothing but delta connected tertiary winding in star-star transformer. What is the main purpose of that? To reduce the harmonics in voltage because our EMF is having E1 plus E3, that is third harmonic also there. To eliminate the third harmonic voltage we are using. So first one is right. It is used to suppress harmonic voltages. And second, it is used to allow flow of earth fault current for operation of protective devices. This is also correct. This is also correct. You will know clearly about this point in the protection system during earth faults. So we use the tertiary winding for protection purpose also. Next, it facilitates supply of single phase loads. Yes. Why? When you place this winding, so what is the problem of star star? Phase voltages are the problems. Line voltage always fundamental. We can connect a three phase load, but problem is single phase load. But once you place tertiary winding, what is the EMF in each phase? Only fundamental means sinusoidal. So we can connect single phase loads also. So that is also correct. It provides low reactance path for zero sequence currents. This is also correct. So yesterday we have seen this. See, there is a path for third harmonic current through this delta connected winding. It is providing very low impedance. Low impedance or low reactance, anything. What is impedance? Sum of resistance plus reactance. Okay, resistance generally negligible. So impedance nothing but almost reactance magnitude. Both are same. Okay. So all four are correct. Option A is right. Yes. Phase voltage, line voltage, same in delta connected. Single phase load, how it is possible means, see, actually in star connection, what is EMF induced without that tertiary winding? Tell me, what is EMF induced in this? Both, na, E1 plus E3, both are there. Peaky wave, when there is no tertiary winding. But after connecting tertiary winding, what is EMF induced in the winding? Sinusoidal, means E3 is not there. Then only E1. Now, single phase load you can connect or not? Yes. Then what is again confusion in that? Once you connect tertiary winding, EMF in the winding will become sinusoidal, means phase also sinusoidal. So you can connect single phase load to that. See, most of you sending the material questions directly, the example questions or any questions. So for that type of questions, if you able to solve, because every question, because so many people are sending, I may or may not watch completely, because there are so many messages. So how many I can reply? So whatever is possible, I am replying, but don't waste the time only at that question. Just leave that question and go to some other question. And after once it is completed, go to standard book, textbook, example questions. Like that, keep on moving, but don't stop at one place. Maybe in some of the questions you may have some data is wrong, or data is not given properly, or options also some one or two options are wrong given. Maybe some of you may get little answer nearby to the given options. Yes, they are there. That possibilities are there here. Okay, everything is not 100% correct. Maybe some errors also there. So whatever you are getting, try it up to the maximum level and check the solutions. If nearly is there, okay, then move to the next question and try to solve in different textbook, different models. Don't keep the same question and watching the continuously as it is not coming, because no guarantee there that type of question only you will get. Just practicing many number of models, that's it. And only don't depend on materials. Don't depend only on material. First complete the entire notes whatever we are discussing here. After that, if you are able to solve whatever there in the material, whatever you are getting. After that, whatever materials, anything, bits and bytes or whatever it is. Some mistakes also there, some printing mistakes also there in some of the questions. So for such type of question, you just read, and if it is not there, just leave that question and move further. And after completion of these practice questions, go to standard book example questions first. Example solved questions. Try to read that questions and try to solve from there. Okay, that will improve your subject. But don't stay at only that question. Okay, so most possible, I am replying to most of you, 90%. Whole machines, I don't know that. So in the first class itself, I said that is whatever we are solving in class work, this is 90% enough for either GATE or engineering service or competitive examination, 100% enough. No need any other material also, because how many you can solve? How much time is there? Okay. Still, you need to recollect the previous subjects, whatever is completed again. Most of the people will do these mistakes. Whatever the subject is going on now, they will concentrate mostly on this. And whatever is completed previous, maybe two subjects or three subjects, and those who join newly one subject or first anything like that, whatever previously completed, that subjects you should recall in a week once. Recall means you no need to read all the topics thoroughly. Just open your book previous subjects, just to open and try to flip the papers. Just have eye contact with each and every page properly. Enough. Some concepts directly you can recollect by eye contact. At least in a week or at least maximum in a month, you should open the previous subjects and you should go through that once. Otherwise, if you keep on moving like this, no, After 4 months or 5 months, whatever you have the previous subjects, all again becomes new one to you. Again, it will take so much time to re-prepare. Okay, take care of that first. See, up to gate examination, we should be in touch with the maximum number of subjects, not only whatever is ongoing. So ongoing is there, almost you are solving. If you concentrate well only in the class, whatever the 4 hours duration we are taking, if you concentrate well, this is enough during ongoing time. Maybe maximum 1 hour you can spend on the next day for the previous class, enough. But you should be having the previous subject preparation while going the ongoing subject. Okay, don't leave the previous subject, anything that is. Yes, maximum is enough. And still, if there is time, refer one time standard books first. Standard like P.S. Bimra or Nagratan Kothari, or those who have J.P. Gupta. Many example questions you can observe there. So that type of books first follow. Okay. You should solve questions. You should solve questions, because then only the mainly what we call confidence will build. So if you listen subject and if you able to solve questions, then only our confidence level will build. Otherwise, if you only reading the theory and not solving any question, means that is completely waste. You should do the practice for new questions. If you are able to solve, if you are able to reach in the first attempt itself, it means yes, you are getting. So by practicing, definitely you will get everything. Yes, material also you can solve. That is, I'm saying in the material, if any data is missing or if you are not able to solve, just leave that question. Don't spend so much time on that. Okay. There may be some errors also in some of the options given. Yes, test will be there. Yes, those who are in third year, if you write gate examination, yes, you should. If you able to get around at least less than 5,000, means good. But most of the people at least not able to qualify that. Yes, previous questions, GATE ESE, both previous questions and some standard books examples also required if there is time. Maximum enough. If still time is there, go through standard book example questions. Okay, next. Now let's see the third one. So we have seen first two connections. What is that? Delta delta and star star connection. So we have in each connection two vector groups. One is 0 degree connection and second 180-degree connection, or 12 o'clock, 6 o'clock. Now let's start the third connection, delta star. Delta star and star delta will have same vector groups, 4 4, each one having 4 vector groups. Let's see how to find that vector groups. Right, third one. Third, delta star connection. Delta star connection. Now in this first connection, let's see first connection in delta star. So same procedure, take up to the polarity and connection. Delta star. Primary you should connect in delta, secondary should be in star. First take the figure. Primary three phases. Secondary three phases. Mark the three phases A, B, C. Secondary side low voltage. Generally we considering every time here high voltage on primary, low voltage on secondary. Conventional. Actually in practical case anywhere you can give supply. LV side also you can give supply. If you want step up voltages, or if you want step down, then give voltage to HV side. Supply to HV side, and load is on LV side. So these polarities are marking by polarity test. Okay, by polarity test we mark and then assign the terminals A1, B1, C1. These are all standard, same as it is. You have to mark for every connection. It won't change again. Okay, now primary is a delta connection, secondary is a star connection. How to connect a delta? Opposite polarities we need to join. So A1 I'm joining first like this, B2, B1, C2, A2, B1 also you can join. So that is I will give in third connection. All four connections you will see clearly here. Next C1 is connected to A2. Delta it is primary delta. Secondary star. How to connect a star? Similar terminals you need to join. So first I'm joining A1, B1, C1, and second connection I will take A2, B2, C2. Okay, this is our neutral. Now we will give supply or source across these three terminals. Input it is, source is given here, and load is connected across these three terminals. Load. Now let's see first vector group. Directly we cannot say here. Directly you cannot say vector group. Delta delta star star you can tell, zero connection, 0 degree or 180 degree, but here directly you cannot say. Okay, for this we need to draw the vectors. From there only we can conclude which type of vector group it is. So before that let's see the voltage relation. Let x is to 1 is the turns ratio, phase turns ratio. It is x is to 1. Then did you remember that relation? Secondary phase voltage is always primary phase voltage by x, same as it is previous connection. We are using this for every connection. Now let us apply some voltage to primary, line voltage V1. Okay, some line voltage applied. This is line voltage V1. Now what is the phase voltage in delta? Both are same. Phase voltage also same, V1 only. Okay, delta no, phase voltage equal to line voltage. Next secondary phase voltage we need to write here. Secondary phase voltage. How to find secondary phase voltage? Using this equation. What is this equation? Primary phase voltage by x. What is x? Turns ratio N1 by N2. Phase turns ratio N1 by N2. So they will give in the numericals in order to find that voltage ratings. Turns ratio is this much. So secondary phase voltage is primary by x. Primary is what? V1. So V1 by x. Okay, V1 by x. Then what is the line voltage here? As it is star connected, line voltage is root 3 times of phase voltage. Okay, root 3 times of that, root 3 V1 by x. Okay, totally how much voltage you applied? V1 you applied. Then how much voltage this connection is giving at the outside or output or secondary side? Root 3 V1 by x. So the voltage applied is V1 and it is producing output voltage root 3 V1 by x, this much. Now just like previous connections, consider x equal to 1 here also. Considering x equal to 1, then how much voltage it is? X equal to 1, so it will be root 3 V1 only. Since x equal to 1 assumed, same turns ratio, x equal to 1 is N1 equal to N2. Then for an input voltage of V1, how much voltage this connection is giving at the secondary side? V1 is to root 3 means 1.73 to V1. Now tell, it is a advantage or not? If you apply some 100 volts, for example, how much voltage you are getting at the secondary side here? 173.2 volts you are getting. 173.2 volts. This is advantage or not? Yes, advantage. What advantage? Even if you take x equal to 1, x equal to 1 means n1 by n2 equal to 1, that is n1 equal to n2, same terms. Actually in previous two connections, delta delta star star, for same x equal to 1, if you apply input voltage V1, how much voltage we got there? Same V1 we got. That is called 1:1 transformer there. But in delta star, even if we use at same number of turns or x equal to 1, this connection will give higher secondary voltages. High, that is high secondary voltage you will get here. How much extra voltage you are getting compared to previous connection? 73.2 percentage extra voltage this connection is producing. It is advantage, no? Actually, if you want high voltage on secondary, what we have to do? We need to increase the secondary number of turns. But here we are not increasing. Same turns we are keeping. Still you are getting very high voltage on secondary. So that is a advantage of delta star. Suppose you don't want high voltage. You want V1 only, not 1.732 V1. You want V1 only. Then when you will get that, let us reduce the number of turns on secondary side. Don't use same turns. Let us reduce that number of turns. At some number of turns, you will get V1 only. That means for the same voltage to produce V1, which transformer required less copper wire? Previous delta delta star star we have seen. Now delta star. Out of these three, which transformer required less amount of copper wire? This connection delta star. Means it is a saving or not? You no need to use for the same voltage. If you want, use delta star connection with less number of turns on secondary side. So copper is saved. So you no need to use more number of turns on secondary, less number of turns we will utilize. So this is the advantage of delta star. So overall, this connection is best suitable for what type of application? Step up application. It is best suitable for this step up. If you want to step up the voltage from low voltage to very high voltages, then we use delta star. Particularly if you see in power system, in the transmission line concept or stability concept, we draw generating power plant. After that, we have one transformer at the sending end. This is power plant alternator. There we have a transformer. Again at the receiving end, after so much distance, again at the receiving end, we have one more transformer here. What is this transformer we use at sending end? Delta star. And what transformer we use at receiving end? Star delta we use. Okay, delta star, because what we do at the generating side always, first we will step up the voltages from 11 kV to very high voltages, 132, 220 like that. So there delta star is suitable because it will, delta star will give very high voltage for less number of turns also. So economically it is like that. Star delta next connection is suitable for step down application. You will get low voltage on secondary side. So there for step down application, star delta is suitable. So at the receiving end we use star delta. Okay. And most of the distribution transformers are delta star only. Most of the distribution transformers are delta star because if it is star on secondary, then only it is possible to connect single phase loads also. For that reason, delta star only. Due to all these reasons, we called the delta star is the most popular connection, the most economical connection, economical, and also you can connect secondary side single phase load or three phase load, anything. So because of all these reasons, we call delta star is the most popular. Okay, now let's see what is the vector group it is. So completed all of you. What? Ram Krishna. We are taking first winding as HV, but we are getting secondary side as HV. Where secondary side? Okay. Yes. You are getting secondary side very high voltages. That is for same number of turns we are comparing actually. This is for same number of turns. Okay. Otherwise, if you have primary turns very much greater, then this is only the high voltage. No, high voltage winding based on what number of turns we are deciding. But what we taken same number of turns. We are comparing for same number of turns. Okay. Muhammad Faiz. Will the classes there for external exams? I don't know about that. What is the difference between single phase and three phase load? Jayanta. See, what is your home load? Tell me. In your home, whatever you are utilizing, they are all single phase loads only. Three phase load. Example is if you visit any shopping malls like that, there you can see lift. Lift is operated by three phase induction motor, not single phase. So for the three phase induction motor, what supply required? A three phase supply required. So that will be a three phase load. Okay. Previously, how to convert kVA to kW? Volt ampere. How to convert kVA to kW? See, kW means what? Active power. P. What is the formula for this? VI cos phi. So here VI we have. VI nothing but what? Volt ampere. So if you have volt ampere multiply with cos phi, you will get kW. Or if you have volt, if you have kW, if you want volt ampere, kW by cos phi. Okay. Hmm. So we are taking tappings on HV side. Yes, but here secondary is LV. HV side tappings means you should give supply to LV there. Okay, but generally for all our connections, we are considering HV as primary, secondary is LV here. But every time it is not same. No? That depends on our application. In our homes, which type of loads we are using? All single phase loads, no, ceiling fans or refrigerators, everything, whatever we are using, they are all single phase loads only. KVR means kilovolt ampere reactive. That is the units of reactive power Q, volt ampere reactive. Yes. Some people use three-phase supply for houses because suppose if there are like big houses, so more number of loads are there. Like suppose take air conditioners, there are two, three, or four air conditioners, and loads also more in that. So then they will take directly three-phase supply. because on one phase you cannot apply directly that 2 or 3 ACs now, because load is very high on single phase. Then they will take 3-phase supply at that time. Okay. You don't consider HVLV, neglect that term first. So because when data given more, doubts also will come very high. So then it is so much difficult to answer. So don't consider this is HV, this is LV. Just this is primary delta, secondary LV. So we are comparing only voltages with same number of turns. That's it. So I taken same turns. The primary also N1, secondary N2, both equal. According to turns, it is same only. Like 1:1, same number of turns. But based on type of connection, we are getting high voltage on secondary. That's it. Now this is not HV, this is not LV. Whatever the voltage you get high voltage, that is high voltage only. Okay. So don't consider that source like that. Yes, transformers close to generators always delta star, because we need to step up the voltage. If we give heavy loads on single phase, then effect is occurs to loads. No, effect actually, suppose on single phase, if you connect heavy load, no, then what happened? There are three phases on transformer, secondary three phases. And on the three phase, if almost load is balanced, the voltage is also balanced. Suppose one single phase having heavy load, other two phases less load, then what is the magnetic circuit unbalanced? Due to this, it will cause different voltages in different phases, and that voltages will appear to load. If voltage is increased, load may damage, or if low voltage will come, load cannot operate properly. Okay, problem to both, that is. Yes, that is due to unbalanced load conditions. Okay, let's see what type of vector group it is first. Same procedure. Primary delta we have to draw first, then secondary star. Let's see how to draw this. Primary side, see, A2, B2, C2 are the outcomes. Drawing primary A phase, A2, A1, A phase it is. A1 is connected to B2. This is B2, B1, B phase. Similarly, B1 is connected to C2, C2, C1, C phase. So primary delta same as it is previous connections. No changes here. Now, so how to draw secondary phasors? Always parallel to primary phasors and in phase each other. Now, observe the figure. A1, B1, C1 shorted on secondary. So as a neutral, A1, B1, C1. Now, at the neutral, this is A1. Now, where is A2? That while drawing that A1, A2, that phase A must be parallel to primary phase A. So if it is A1, A2 should be in upward direction. Then only they will in phase. A1, A2. This is A phase. Okay. Small a, capital A, both parallel. Next, from the same neutral, B1, B2. If it is B1, if this point itself B1, where is B2 now? Right side or left side? If it is B1, right or left? So I said two ways. One is you should consider primary B must be in phase with this, or in clockwise you should get B. If you take left, you are getting wrong, because clockwise you are not getting B next. So if it is A phase, B you should get in clockwise direction only. So if it is B1, B2 should be in this direction, parallel to primary. This is B1, this is B2, B phase. Okay, now clockwise A, B. Next C will come. Next C1, C2, draw directly. C1, C2, C phase. Okay, now primary delta is drawn, secondary star is drawn. Still now also you cannot answer directly which vector group. Why? I said when there is a delta connection, you should draw internal reference star for a clock connection. In order to say a clock connection, you should draw internal star. Okay, so draw that internal star. Draw the internal star. Now where is ABC in that? That depends on vertices. So for that, go one time previous slide. That is A2, B2, C2 are the outcome terminals. So circle that A2, B2, C2. So this is corresponding A phase. This is B phase. This will be C phase. Now this star, primary reference star and actual secondary star, both we have. Now both compare. Let us coincide neutrals of both stars. Then check any one phase. Now we are comparing always capital A phase. Okay, comparing with A phase. Observe here. Capital A is pointing 12. Capital A pointing 12. Now very small a. If you move this small a as it is here, this small a will come exactly here. So you should just coincide or place both the neutrals in phase. Then check capital A and small a. Small a you will get exactly here. Small a it is. Now exactly if you take exact angles, it will okay. It will point 11. Now what is the time it is? Minute hand is pointing 12. Short hand or hour hand is pointing 11. This is 11 o'clock connection. Or how much angle between these two? 30 degrees. Now lead or lag. How to say lead or lag is always we will consider secondary phase A. Secondary phase A. Primary is our reference. Secondary phase A we will check what happens secondary phase A in vectorial direction. Vectorial direction. Secondary phase A leads primary phase A. Secondary phase A, small a leading capital A. That's why it is called 30-degree lead connection. 30-degree lead connection. Okay, we have 30-degree lag also. Small a will point at 1. That is 30-degree lagging connection. And simply we represent it is as dy11 connection. Okay, this is dy11. Delta star 11 o'clock. Clear all of you? Not 10, because if you draw with exact angles, definitely it will point maybe here according to figures small a looking like at 10. So it is not 10. You will get exactly at 11. You also draw in your papers with the exact angles by taking scale measurements and all. You draw the figures, then definitely you will get at 11 it is. Okay, see, simple. This is like 0 degree, considered 0 degree. Now what is this angle? 90 degrees. Now this angle how much? 90. Now, what is the angle between phase A and phase B in three phase? 120 degrees. And what is this angle? 30 degrees. 30 degrees. So 30 degrees means one digit, like that. Okay. Shreyas Sesi, clear now? How to say 11 o'clock it is. Secondary phase A, we will compare. Secondary phase A leads primary phase A by 30 degrees. That's why it is the 30-degree leading connection. No, phasors. Phasors always vector. That is vectors direction always what? Anti-clockwise. No. So accordingly, we are considering secondary phase A leads by primary phase A 30 degrees. So leading connection. Okay. No, that is not right. That is not 5. This is 11 o'clock only correct. Okay. So whatever there in material, that is not exact one. So we need to change that. So follow this exactly. This is the correct one. Okay. We shall increase some speed. So if we increase the speed, you people only listening now, what is happening? Mohammed Faiz, that you should contact the management because I don't know during when you have the external examinations and all. Okay. How again lead lag? So I again clearly given no small a when you place both the neutrals coincide. So where you are getting this is small a you are getting here small a. Now in vectorial direction, vectorial means anti-clockwise always. So in the vectorial direction, small a leading no small a is first. After that capital A is there. That's why small a. So we always compare secondary voltage with primary voltage. That is secondary phase A with primary phase A. Based on that leading we call it is. I don't know Bosle. Okay, next. This is first connection in delta star. Now second connection in delta star. So you people try that. Second connection, what you need to do is primary delta same as it is. Don't change. Secondary star short circuit A to B to C2 means neutral is at A to B to C2 open here, load is at A1 B1 C1. Now draw the figure, check what connection you will get quickly, tell the answer. Mamata, how to draw Y connection in vector form? This is only no Y star. How we have drawn secondary depends on primary phases, parallelly we drawn in phase. Check. Yes, 5 is right. 5 o'clock that is. Satish. DY11 may be for distribution transformer, may be for power transformer. For anything, same procedure. This will not change for distribution and power transformer. Both are same. Anything you can use DY11. Okay. Check all of you. Which connection? Yes, right. Abhinesh, Vinita, right. 5 o'clock. Yes, good. Soundarya, right. DY5 it is. Yes, 150-degree connection you will get. Good. See, I'm drawing second connection. Primary delta, I'm not changing, same as it is. So draw quickly it is. Primary delta, I am not changing, same. Only secondary star, I will change. Like the different possibilities, you can connect the load and source. A, B, C, A1, B1, C1. Primary delta, I'm not changing, same connection it is, no change in that. And secondary side, now I will take A to B to C2 as the neutral point. Anywhere you can do, anywhere you can short. Source is now same point, source is at same terminals, but load is changed. A1, B1, C1 is the load. Now which connection it is? So if, without changing primary, if you change only secondary, you will get exact opposite connection to previous. So previously what you got 11 now, now exactly opposite you will get 5 o'clock, exactly opposite. If you change only secondary, you will get exact opposite. 5 o'clock it is. Primary delta same as it is. I'm drawing, no change. A2, A1, A phase, B2, B1, B phase, C2, C1, C phase. Okay, this is same. Now secondary star. A2, B2, C2 is the neutral point. So this is A2. If it is A2, where should be A1? Towards a downward direction. This is A2. This is A1, A phase. Now it is parallel and both satisfying. Next, from the same point, B2 it is. If it is B2, B1 should be in this direction. B2, B1. Remaining C2, C1, C phase, B phase. Okay. Now take the internal star for delta connection. Wherever you have delta, you need to take. Draw the internal star. For clock connection only, we are considering this internal star. A2, C2. This is A phase, B phase, C phase. Now take a clock and place it. Observe. Capital A pointing same 12 only. Capital A is towards 12 direction. Vertically up. This is capital A, 12. Now let's move this neutral point to this neutral point such that both coincide. Then you can observe small a will come exactly here. Small a. Any one phase you can take, A phase, B phase, C phase, anything. Angle you will get. But for a proper clock, this minute hand should point 12 now. That's why I taken A phase is pointing 12. Or B also you can take. Same connections you will get. Now small a will point exactly here. Small a. So it will be 5 o'clock connection. And what is the angle? 5 digits. 5 into 30. 150-degree connection it is. Now you may get doubt. This is lagging or leading. So generally for this heavy high angles like about 120 or 90 degrees, you can directly call 150 degrees. Or you can say 150-degree lagging connection. Because what is the small a compared to capital A? Vectorial direction, anti-clockwise. Now small a lagging here. Small a lagging capital A by 150 degree. So you can call 150-degree lagging connection or directly 150-degree connection. Means that 5 o'clock connection. Or simply dy phi it is represented. Okay. Dy phi. Clear all of it is how to draw vectors. Now in third connection, I will change primary delta also. Primary delta also I will change. Check how it is. Completed all of you. 210-degree lead also you can say. 210-degree lead. So to avoid that confusions, no, to avoid this confusion, 210 degrees suppose given, there you may get doubt. This is leading or lagging. Or 150 degrees given. Then you will get again doubt. This is lagging or leading. So to avoid these problems, the standard we follow on the nameplate is this one. Like this we indicate with the clocks 1, 5, 7, 11, 6, 12. Like that we indicate on the nameplate so that no confusions will be there. Otherwise 150-degree connection means somebody may take lagging, somebody may take leading, what it is. Then to avoid that, this is the best standard to be followed. Clock connection. Okay. See the third connection now. Completed all of you. And today one of your friend itself shared one small video regarding third harmonics or oscillating neutral. So with the simulation given it is. So I will show you. Wait 1 second. Okay, watch this one. This is oscillating neutral with due to third harmonic effect. So this is third harmonic. Now see fundamental and third harmonic both oscillating neutral. Observe here this point. See neutral oscillating. Now you can observe with three vectors A, B, C, R, Y, B, three phases. See this white arrow is there. No, neutral is oscillating. Neutral is not stable. Neutral is oscillating here. Neutral oscillating this point. Okay. And what is the waveform of this peaky wave like this? Because of both fundamental and third harmonic, the resultant shape is peaky wave. So three waveforms we have: red, yellow, blue means what? In all three phases, what is EMF induced per phase? Peaky wave. E1 plus E3 both are there. That's why it is peaky wave. And how neutral oscillating? Here you can understand. See this one. Because of that neutral is oscillating. See, it is not having a fixed neutral whenever it is rotating in anti-clockwise direction. Okay. That is simulation. Okay, good. Why we take reference here? So you take B also, no problem. Pallavi, you can take B also. Okay, yes. Is shared by who? Yes, Aravind. Aravind only shared this video. Three phase suitable. Single phase load only problem with oscillating neutral. Three phase no problem. Three phase, what is the line voltage? Three phase fundamental only, no? In the previous course, 2 days back, star connection, delta connection, there are given. Star connection, single phase EMF is peaky wave. But what is the line EMF? Sinusoidal. That is fundamental. You can connect three phase load, no problem. Problem for single phase. See one more time. See this. This is only third harmonic. Okay. This is the third harmonic. Observe up to that again. The small arrow is rotating now in anti-clockwise. That is the third harmonic EMF. Third harmonic EMF. Now observe. Third harmonic EMF rotating quickly, but fundamental is rotating slowly. Slowly. See, third harmonic rotation is high. This is now three phases. Now three phases. See, neutral oscillating. Observe. Neutral oscillating. Okay. So yesterday I shown just two reference points, 0 degree and 90 degree, 30 degrees. Okay. So first clearly given here. This is only third harmonic. This is only third harmonic. This white small arrow is only third harmonic. Now see, fundamental third harmonic, only one phase, peaky wave. Now three phases. See, this is three phases. Okay. Okay, enough. Now phase voltages. So these waveforms are phase voltages. Three phases, phase voltages. Phase voltage only peaky wave. Line voltage sinusoidal. No? Peaky wave, that is peaky wave. That is peaky wave. Peaky wave, na it is. Observe. This is only third harmonic. Now, third harmonic fundamental, both. Then what is the resultant? Peaky wave. This red one is peaky wave. That is directly resultant given. Okay. See, actual neutral point is this is. Actual neutral point of fundamental is this. But due to third harmonic, what happens to that neutral point? See, if there is no third harmonic, this neutral point will be here. With respect to the three phases will rotate. But now what is happening? Due to the third harmonic, neutral point is shifted. Then it is rotating with a different magnitudes. Okay. Okay, right. Okay, not no need enough. Now let's see the third connection in delta star. First two connections are 11 and 5. Let's see the third connection. Third connection. Third connection in delta star. So primary side, I am changing delta now. Check how will change. 1 second. Okay, now audible? Yes. Yes, maybe people now you are getting doubt why A1, B1, C1 is not taken on primary set. If you take A1, B1, C1 also, again same connections will repeat. But what main thing we need to change here is observe. Observe now. In the previous two connections, between A2 and B2, between these two, which phase is coming? Observe. Phase A is there. Observe. A2 to B2. Phase A is coming. Similarly, in this connection, observe A2 to B2, which phase is coming now? B phase is coming. So that is we need to change mainly. Between two terminals, the phase we have to change between two terminals. That is our one more connection. If you take A1, B1, C1, and if you take this star again two times, almost same connections again you will get. Your connection will not change. Vector group will not change. You try it if you want. Okay, you try that. So in this A2, B2, between A2, B2, we are changing phase, direct phase we are changing. So this is another delta. Now secondary side A1, B1, C1 shorted in third connection. Fourth connection short A2, B2, C2. You will get total four vector groups. Okay. Now again draw the primary delta first. Yes. If you change terminals, your vector group will not change. That's why this connection is different. Okay, whether you take A1, B1, C1, same connections again you will repeat. That's it. If you want, you try that again after completion of class, you try that. Now primary delta I'm drawing first. A2, B2, C2 are the outcomes, but observe I'm drawing primary delta starting A like this. This is my A1, this is my A2, A phase it is. ABC anyhow you can draw, anyhow you can take like this also, like previous connection A2 here, A1 here, A here. I taken previously like this only, no, for all A2, A1, A phase. But now I am taking A2, A1 like this, A phase, and B will come here, B phase. Anyhow you can draw, but why I am drawing like this is I need A phase because in all connections A I am pointing 12. That A I am pointing 12 now. That's why accordingly I taken A1, A2 like this. Okay. Now A2 it is. Observe the figure. A2 is connected with B1. A2 is connected with B1. A2 is connected with B1. So it will be B1, it will be B2. This is B phase. Now again observe B2 connected with C1. B2 connected with C1. B2 connected with C1. C1, C2. So total three phases. Delta we got. Then if you take like this, no? Now if you draw internal star, observe internal star. Now where is ABC inside? Where is ABC inside? Whatever vertices A2, B2, C2 are the outcomes. So circle that A2, B2, C2. So this will be A phase same as it is. It will be B phase same as it is. It will be C phase same as it is. But I will show you here itself. Check what happened if you draw like previous connection. How we are drawing previously like this. A2, A1, A phase. Okay. Next A2 connected with B1, B1, B2, B phase. Anyhow you can draw like this also. It is also right. Now B2 connected with C1, C2, C phase. Now if you draw internal star here, now check where you will get A phase. This is A2, B2, C2. So this will be my A phase. It will be B phase. It will be C phase. Now if you draw like this, if you draw like this, A is not pointing that internal star, this red one, capital A is not pointing 12. Then it will be difficult for me to say clock directly. For that reason, I started like this. Okay, all of you clear why I drawn like this? Any vector you take, any vector. If you can take C vector here, B also you can take. Angle you will get same. Angle will not change. Any vector you can take. But I am following capital A for all connections as is same sequence. Capital A only I am considering. That's why I drawn delta accordingly. Because people will get doubt. Previously you taken A to A1 like this, but now you taken A to A1 like this. You take anywhere you take. There is no any condition to draw only like this. Any way you take. Next, secondary star we need to draw. Check secondary star. A1, B1, C1 shorted. So neutral is at A1, B1, C1. This is A1 neutral A1. Now where A2 I have to draw? You have to check for to draw that A phase the primary A first. This is our A1, A2. If it is A1, draw parallel to primary phase A. This is A1. This will be A2. This small a parallel to capital A. Both A1, A2 in phase. A1, A2 in phase. Okay. Next, from the same A1 neutral, B1, B2. If it is B1, observe B phase of primary like this. So drop exactly parallel to that B phase. B1, B2. Similarly, C1, C2, C phase. Now secondary star we draw. Drawing secondary always parallel to primary, exactly in phase. That's it. Parallel in phase. Remember only 2 points. Parallel in phase. Secondary phases parallel in phase with primary. Now take a clock. Take a clock. Now this is primary side. Our reference star is this. Capital A pointing same 12 now. Capital A pointing 12. Now small a is pointing exactly. If you draw, it will come at 1. Now what is the small a with respect to capital A in vectorial direction? Small a in the vectorial direction. Why vectorial? Vectors always anti-clockwise. Now that's why we are considering that. Small a lagging. See, out of these two, which one is first? Capital A is first here in the direction. So small a lags. Small a lags capital A by 30 degree. So we call 30-degree lagging connection it is. Or 1 o'clock connection. Or simply we represent dy1 connection. Okay. dy1 connection it is. Now for fourth connection, what you will do now again? For fourth connection, keep primary delta same. Change the secondary side neutral. So now we taken A1, B1, C1 now. Now you take A2, B2, C2. Take it is. Taken all of it is. Yes, any phase you take. Yes, right. So there is no fixed to take A phase. You take B also, you will get answer. Same answers you will get. But I am following one similarity for all connection. That's it. Draw upwards means which one I have to draw upward? Yes, good. For fourth connection, yes, right. 7 o'clock, right. Exactly one opposite you will get 7. One opposite what? 7. 7 o'clock is the fourth connection. No, see this fourth connection now. All of you completed third one. For fourth one, take the same delta, and star I will change A2, B2, C2. I will take neutral. Okay. Fourth. So you try to draw star delta, that is enough. If you able to draw that star delta, you got all the connections. Generally, star delta only little confused compared to these remaining connections. Primary delta, I am not changing. A to B1, B to C1. Dot is connected with undot. Dot connected with undot for all. This is also a delta. And source is connecting at A to B to C2, same terminals. And secondary side, previously A1, B1, C1 is neutral. Now A to B to C2 is neutral. A to B to C2. Okay. Draw this figure. So I will come back just 1 minute. Primary delta, no change, same as it is previous. Same as it is previous. A1, A2, A phase, A2 connected with B1. It won't change. B1, B2, B phase, B2 connected with C1, C1, C2, C phase. Okay. Primary delta, same. Now secondary side, which are connected at neutral, A2, B2, C2, we connected. So secondary side neutral is at A2, B2, C2. This is A2. Now where is A1? Now you have to check for primary A phase. If it is A2, observe primary A phase one time. You should draw exactly in the downward direction. This is A2. Then it must be A1. So that both are parallel and in phase. Capital A and small a. Right? Next, from this point, B to B1. So if it is B2, where B1? Exactly in the upward direction. B to B1. This is B to B1, B phase. Primary B phase, secondary B phase, parallel in phase. Similarly, C to C1. C to C1. C phase parallel. C phase, C phase. Now, which connection you will get? A to B to C2 are the outcomes on primary. So draw internal star. These internal phasors are very important. If you by mistake change it is, your connection will change. A, B, C. Now take a clock. Capital A pointing 12 only. Capital A pointing 12. Now small a. Let us take this neutral coincides with this neutral. Then small a you will get exactly like this. Small a here. So that small a is pointing towards 7. This will point 7. Okay. Now what is the time it looks in the clock? 7 o'clock. So simply we call it is 7 o'clock connection. Or what is the angle in the lagging direction? In this lag, this is lagging. Leading is this side. Anti-clockwise is lead. So this is 210°. 7 digits means 210° connection. Or simply we represent as dy7 connection it is. Okay. So these are the 4 connections. What are the total? 1, 5, 7, 11. Total four connections, four clock connections or four vector groups we are getting in delta star. Four vector groups. So all of you completed. Yes, if you take A1, B1, C1 as a source side, A1, B1, C1, capital A1, B1, C1, again same connections will repeat. So no use of that taking again. That's why I changed by taking same A to B to C to internal connection, little I changed. So we got total four connections. Like that, if you, maybe you people will get doubt. I will take A1, B1, C1 on primary side source. You take again out of these four connections only will repeat. Okay. Yes, good. Yes, 150-degree leading connection also you can call. Generally for lagging, we don't call. Whenever it is lagging, directly we can write 210-degree. Otherwise, same you can call 150-degree leading connection. Okay. Only for 30-degree, we indicate whether it is lead or lag. But for 150, 210, we don't take leading or lagging like this. Because little angle, 30 degrees this side, 30 degrees this side. That is only we consider lead or lag. For 150, 150 means that is we have to consider conventionally lagging only, that is 210 also means lagging only we have to consider. Otherwise best one is either 157 11 like this. This is the best representation. No confusions at all. Okay. Okay. You practice whatever the remaining chances A1, B1, C1, whatever is there, you take and practice. So four connections we have drawn. Let's see the features of delta star. Right? Features. Features of delta star. Delta star. Now, one important point here is regarding voltage rating. How much voltage we applied? How much voltage we applied? V1. How much voltage we got? Root 3 V1 for the same number of turns, x equal to 1. Means this connection is giving higher voltages on secondary side compared to previous delta delta and star star. It is producing highest secondary terminal voltage. This is also one of many times in examinations, competitive examinations question. Which three-phase connection will give highest secondary terminal voltage? Which connection will give? Delta star will give highest secondary terminal voltage. Okay, right, that first point. For an input voltage of, for an input voltage of V1, this connection produces, this connection produces an output voltage of, an output voltage of root 3 V1 for the same number of turns also. I said same number of turns x equal to 1, we will compare for all connections. Okay, for the same number of turns also. Actually, for same number of turns, what is the previous two connections voltage? If you apply V1, V1 only that connections are giving, but it is giving higher voltage on secondary side. That is the nature of that delta star. Because of that combination, you are getting higher voltage on secondary. But if you take star delta now, your secondary voltage will reduce. That is due to connection. Second point. Right. This connection produces, this connection produces how much extra voltage on secondary when compared to primary side? If primary is V1, secondary root 3 V1. Root 3 V1 means 1.732 V1. So this connection produces 73.2% extra voltage on secondary. Okay. how much voltage it will produce additionally, means 73.2 percentage voltage. Next point. Now tell me, what is the shape of EMF induced in this connection? Sinusoidal or peaky wave? Sinusoidal, because there is a delta. I said in previous class in a note, there must be a closed path either on primary or on secondary for third harmonic current. Means delta should be there any one side. Delta should be there any one side. Then EMF is always sinusoidal. But only in star star we don't have delta. The closed path is not there because delta is not there. That's why what we did previously, a tertiary winding or delta connected winding we placed. Then EMF sinusoidal. Okay. So as primary delta, EMF induced is sinusoidal always, right? In this connection, the EMF induced is always sinusoidal. The EMF induced is always sinusoidal. Okay, always sinusoidal it is. Next, fourth point. Now, this connection is suitable for both single phase load and three phase load or not? Yes. Single phase means one line to neutral, whatever we connect, that is single phase load. Line to neutral. And line to line, like that, if you connect in three phases, then that is a three phase load. Now, it is suitable for both secondary side neutral available, single phase load you can connect, and three phase load also you can connect. So, right there. It is suitable for both single phase and three phase loads, both single phase and three phase loads. So these are some important features of delta star connection. Now delta star is suitable for what? Mainly step up application. Step up it is suitable, and you can use for step down also. For anything you can use, but main application is step up, because what is the voltage you are getting on secondary? Higher voltages you are getting. So if you want higher or secondary side more voltage compared to primary side, then you can use delta star. Generally we preferred in the transmission side just after alternators to step up the voltages. And again, same delta star transformers we are using for distribution. Why distribution also it is suitable? Yes, in distribution, if there is delta star, due to star on secondary, single phase loads also possible to connect. This is the reason why we are using again in distribution delta star transformers. Okay. Next, the last fourth connection is star delta connection. So can anyone try one connection in this first with your previous experience in the three connections? Any one connection you try to draw. First, just I will draw the connection. You try to say which vector group that is. So I will draw the connection. Take it is first one in this. Same as it is delta star 4 we have 1, 5, 7, 11 here also. I will draw the figure. Tell which vector group it is. Take the figure. This is star delta in one of the gate previous question for 2 marks. They given one diagram, just whatever I'm giving now like that, same as it is. You need to answer what is that vector group. Okay, same as it is, whatever I'm giving, same. Primary star. So connect any three similar terminals. I'm connecting A1, B1, C1. This is the neutral. Okay. Secondary is what? Delta. Secondary is delta connection. Delta means opposite polarities you need to join. For example, I am joining like this first. A1, B2, B1, C2, C1, A2. Okay. Now across this A2, B2, C2, source is connected. Across this A2, B2, C2, load is connected. Tell me which vector group it is. Out of 4, 1, 5, 7, 11. Which vector group? Try to tell all of you. Which connection it is? Yes. Okay. Some of you given 1 and 11 also given, most of you 7. Okay. So all are there. 1, 5, 7, 11. Okay. So very good. Yes. Okay, good. The answer for this is 1 o'clock connection. This is 1 o'clock connection. This is 1 o'clock. Yes, good. This is 1 o'clock. Okay, enough. So listen now. So I will tell this connection, at least practice the remaining 3 connections in this. At least remaining 3 you need to tell. Okay, I will draw only figures. You need to tell what connection you will get further vector group quickly. Now listen first voltage relation, then I will draw vector group of this voltage relation. See, x is to 1 phase turns ratio. Then if you apply a voltage V1 to the primary side, if you apply a voltage V1, how much voltage this connection will give? Just like previous connection, we need to check it is. Now this is a star connection. Line voltage is V1. So what is the phase voltage? V1 by root 3. Okay, phase voltage in star. Now secondary phase voltage. What is the formula? Primary phase voltage by X. So if primary phase voltage is V1 by root 3, what is the secondary phase voltage? Primary by X. Now this is the secondary phase voltage. V1 by X root 3. V1 by X root 3. Okay. This is secondary phase voltage. Secondary connection is a delta connection. So line voltage, phase voltage same. So same as it is right here. V1 by X root 3. Therefore, if you apply a voltage V1 to the input side or primary side, how much voltage you are getting on secondary here? V1 by X root 3 you are getting. Okay. Now let us consider X equal to 1, just like previous connection. V1 is to V1 by root 3. Since X equal to 1 assumed, that means how much voltage it is giving? For a input voltage of V1, it is producing at the output 0.577 V1. 1 by root 3 means 0.577. Okay. So secondary side, how much voltage you are getting here? Low voltage. Actually, how many turns we are using? Same number of turns. N1 equal to N2, X equal to 1. That's why. N1 equal to N2 means we should get same voltage actually, but we are not getting. But we are getting low voltage. Low voltage it is getting. Now, by the nature of this connection, it is suitable for step down or not? Yes. It is giving very low voltage on secondary side. Like it is like step down. Primary is high voltage, secondary is low voltage. Step down type it is. Even for same number of turns. So this connection will produce low voltages on secondary side. Now, how much low voltage it is producing for same number of turns also? How much? This is an important question, little confusing in examination point of view generally. How much voltage it is producing? 57.7% it is producing compared to primary. How much less it is producing compared to primary? 42.3 percentage less voltage it is giving. Clear? Don't confuse in the 2 percentage. When compared to primary voltage for same number of turns, how much voltage this connection will produce at secondary? 57.7% of primary it is giving. But how much less it is producing? 42.3% less voltage it is producing on secondary side. Clear? Don't confuse in these 2 points. Yes, good. This is about voltage relation. Now let's see the vector group. How to draw vector group? Most of the people will do mistake is they will draw delta first again. They will draw delta first and they will draw star after that. Always for every connection draw primary phasors, because where you are giving supply first, primary, whatever the winding you are giving supply, that connection you have to draw. Which connection you are giving supply? Star. So draw star first. How to draw that star? So I am drawing like this. Observe the figure. A1 B1 C1 shorted. A1 B1 C1 shorted. So this is A1 A2, and from the same point B1 B2. This is A, this is B, this is C phase. C1 C2 C phase. Okay. Now people will get doubt. So why you taken star like this? Why star is drawn like this? Now can you draw star like this? This is also a star connection only 120 degrees. Can we draw, or can we draw star like this? This is also a star connection. Yes, you can draw anything. Anything you draw. But why I drawn like this? Again, same reason. I taken A is pointing like 12 o'clock. A is pointing 12 in a clock. Like that, I taken A vertically here. Okay. Otherwise, any connection you can take. Any star is right. Now, primary star is drawn. Then secondary delta we have to draw. Check how to draw secondary delta. Secondary delta we need to draw. Secondary A phase parallel to primary A phase. So I'm drawing first it is small a parallel to capital A, and this is A1 and this is A2. A1 A2 A1 A2 in phase. So A phase is drawn. Next, observe figure. A1 is connected to B2. A1 is connected to B2. So you have to start B phase from A1 now. From A1, this is A1. A1 is connected to B2. So this is B2. Now where B1 I have to draw? Like a delta we should draw it is, or from this you have to draw B phase parallel to primary B phase. This is B2, so I have to draw exactly in the upward direction. This is B1, this is B phase. Now small b capital B both parallel. Check. Small b capital B both in phase. Okay. Small b1. Clear? Next, B1, observe the figure. B1 connected with C2. So from B1 starts C2. This is C2. C1. This is C1. This is C phase. Small c, capital C, both are parallel. Okay. So delta we have drawn. Don't draw. Maybe I can expect that most of you drawn delta directly like this, and there you will indicate. That is wrong. Don't draw secondary vectors directly. Secondary always you have to follow the parallel with primary side always. Same procedure like previous connection. Don't draw secondary delta directly. Okay. So star is primary, delta is secondary. Now which connection? So this is A phase as it is. You can place. Now draw internal star here. Now where ABC internally? That is important. In internal star, ABC is which one? For that what I said? You observe load terminals A2, B2, C2. Circle that. A2, B2, C2. So A2 means this is corresponding A phase, small a. This is small b. This is small c. Now take a clock. Now taking a clock. Now in that clock, place this A phase capital A and small e. Let us coincide both the neutrals. This neutral and this neutral coincide. Then capital A is pointing 12 and small a exactly will point at 1. Small a. This is 12. This is 1. Now this is 1 o'clock connection or 30-degree lag. Small a lagging. Capital A. So 30-degree lag or YD1 connection. Okay. YD1. All of you got it now? Why B is not in downward direction? If you draw small b, suppose first small a2, a1, from here b2 now. If you draw in downward direction, how delta will close? Delta will not form now. If it is b2, b1, this is b phase. Now from where you have to draw c2? From b1 you have to draw. How can you draw? Can you draw like this? Then it is not coming parallel to this primary phase. It is not satisfying. Okay, wrong it is. Clear? Yes, same. 11 o'clock, capital A is at, you are saying 11, and small a is at 12. So same angle now. Now let us make that capital A to bring towards 12. Then you will get 1 o'clock only. Both are right. Voltage relation we have seen for all connections. Again, observe one more time. X is to 1 is the turns ratio, phase turns ratio. Then if you apply a voltage V1, line voltage, as it is star connection, what is the phase voltage? V1 by root 3. Now secondary phase voltage we need to write here. How to write? Using this equation. Secondary phase voltage is primary by X. So that V1 by root 3 by X or V1 by X root 3 it is. As it is delta connected, what is the line voltage? V1 by X root 3, same. So that is I taken. Okay. Okay. This is first connection. 1 o'clock it is. Now for second connection and third connection and fourth connection, for all these four connections, you no need to touch primary star. Means this one you no need to touch. Keep this figure as it is, the primary star as it is. Change only your delta. Change only your delta. You will get total 4 connections. No need to change primary side. See, I will show you the second connection. Observe. Second. So you need to tell what vector group it is. Take the figure. Primary, I am not changing. Same. So in previous gate examination in one of the year, we have one question directly like this. They given one figure. You need to tell what vector group it is. Okay, I will show you that question also. That is given for star delta only. Given for star delta only. Take the figure quickly. Primary star, I am not changing. Same neutral I will take. This is same neutral. And source is connected at A to B to C to. I don't change primary star. Same. No need to change. Only delta I will change in 4 ways. See, previously I joined A1 with B2, B1 with C2. Now I will take A2 with B1, B2 with C1, C2 with A1. This is also a delta. Opposite polarities only you should join. Okay. A2 I connected with B1, B2 with C1, C2 with A1. Now load is connecting at A1, B1, C1. This is load. Now what vector group it is? Tell me. Draw the figures quickly. Which vector group you will get? Or what is the clock of this? Hmm. 11, 7. Yes. Yes. Most of you given right. That is 11. Some of you saying 7 also. This will come 11 o'clock. It will come 11 o'clock. Not 7 it is. It is a 11 o'clock connection. Check once how it is. Primary star I am not changing as it is. Primary star same. A1, B1, C1 shorted. A1, A2 here. B1, B2, C1, C2. Okay, this is same. No change in the primary star. Now secondary side. Secondary side delta. First observe delta. A1, A2. First draw A1, A2. Draw A1, A2 first. How to draw that A1, A2? Parallel to this primary. This is let A1. It is A2. A1, A2, A phase. Both in phase parallel exactly. Next. A2, observe the figure. A2 is connected with the B phase. A2 is connected with B1. A2 connected with B1. This is A2, no? Start from here B1. This is B1. Now in which direction you will draw that B2? Like this or like this? Clockwise you should have ABC. So follow here only, right side only. If it's B1, B2 will be like this. Now check one time. Small b and capital B, both are in phase or not? Yes. B1, B1, B2, B2. Both in phase. This is right. Okay, B1, B2. Next, observe the figure. B2 connected with C1. B2 connected with C1. So directly you can draw the other phase now. Once you draw two phases, C1, C2, C phase. Now draw the internal star in delta. Internal star. Okay, like this. Now, where is ABC inside? That depends on vertices. So, what are the vertices? Yes, this is not 11. What are the vertices here? A1, B1, C1 are the vertices. No. Yes, A1, B1, C1 are the vertices. So, A1 is here, B1 is here, C1 is here. So, as it is A1, this is A, this is B, this is C. So, this is 7 o'clock, not 11. Yes, those who got 7, you are right. This is 7. Now let's take the primary phase, capital A pointing 12. Now small a, let us coincide the both the neutrals. Then small a, you will get exactly at 7. This is small a. Okay, this is 7 o'clock connection. Or in the lagging or clockwise direction, 210-degree connection, 210-degree. Or simply we represent YD7, star delta 7 o'clock connection. Okay. Yes, good. 7 is right. Now remaining two I am not giving. Remaining two I don't give. So you try the remaining two connections. What are the remaining two connections? 1, 7 we got. Remaining two means 5, 11. 5, 11. So for that what you need to change? Don't change primary, same. But only in delta what you will change is in the previous two connections or between A1, B1, which phase is there here? A phase is there. Between A1, B1, A phase is there. Now what you will do is between A1, B1 only you connect like this. Join A1, B2 here and take A1, B1, C1 only the load. Now between A1, B1, B phase will come. So you need to change internal phase, then load connection. Like that for first connection, again A2, B2, C2. There also you observe one time this A2, B2, C2 first connection. What is the phase between A2 and B2 here? A phase. Between A2 and B2, A phase is there. Now what you will do is keep same figure. Now join like this. A2 is connected with B1. Then between A2 B2 you will get B phase. Just like our previous delta star. However, I changed there. Like that you need to change. So I'm leaving that is to you only. You practice. And I will show you the previous gate questions. I will show you the previous gate question. Check once. All of you completed. This is first connection in star delta. This is 1 o'clock. And this is second connection in star delta. It is 7 o'clock. Now there is balance 5, 11. That too you need to try. See, I will show you the question. Observe. See this question. You need to tell which vector group it is. Which vector group? Star delta it is. Star delta. Yes. We have drawn it is already we have drawn. Yes, good. Just now we have drawn this connection. Yes, all of you right. All of you right. Option B, YD1 is the right answer. Just now we have drawn, observe. First connection it is same, this one. A2, B2, C2. Secondary side also A2, B2, C2. And between secondary A2, B2, A phase. A2, B2, A phase is there. Same this one also. See, between A2, B2, this is A phase. This is B phase, C phase. Okay, same connection, 1 o'clock it is. And here they did not mention dot polarities, but they given only these terminals A to B to C to A to B to C to. Same procedure you follow and you will get 1 o'clock. Okay, now features are there, write that features. After that we'll take break. Right, features of star delta. Features of star delta. Features of star delta connection. Right, the first point. For an input voltage of V1, for an input voltage of V1, this connection produces an output voltage of how much it is? V1 by root 3 it is. V1 by root 3 for the same number of turns, because x equal to 1. Actually V1 by x root 3, but x equal to 1 we are assuming. So output voltage of V1 by root 3 for same number of turns also. For the same number of turns also. Delta delta giving V1 V1. Star star also giving V1 V1. Same voltage. Delta star is giving V1 root 3 V1. But star delta is giving V1 V1 by root 3. Okay, just remember the sequence. I will give all these points in the note, one table I will give. So remember, important for calculation of direct questions you will get in engineering service or competitive examination, particularly not for gate. For gate they don't ask directly this, they will ask like previously yesterday we solved some questions, line voltage how much, secondary line current how much, like this type of questions. But for engineering services and competitive examination, direct questions you will get from these relations. Okay, write this. Second point, how much voltage it is producing on secondary? 57.7%. How much less it is producing than if it is asked? 42.3%. So write the two statements clearly here. This connection produces 57.7% of voltage on secondary compared to primary. This is for same turns only. Otherwise, whenever turns is changing, if x value will change, then again voltages will change. Okay, this is for same number of turns we are writing. Next, third point, this connection produces 42.3% less voltage on secondary compared to primary. Okay, less voltage, how much less means this percentage, how much it is giving means 57.7%. Generally it will confuse the people, so take care while reading the question during examination. Presence of mind during examination is very very important. So there are some people, they said that they prepared very very well, but still they got the rank is above 1000. The reason is what? So in getting a good gate rank, only preparation is not at all important. You prepared well enough, but another thing required is the presentation skills is very important for competitive examinations. If you are unable or not able to uh, give the exact data simultaneously during the examination, you cannot get any good rank again. Okay, first you should not have any fear during examination, and you should have good confidence on every question to solve, and that is on every subject first you can able to solve. And while reading one question and one question one after other, if one question is not getting, then most of the people will be thinking about only the previous question. So just leave that question and go forward. So move forward, and after completion of all whatever you are able to solve, then come back to the starting questions again. Don't think at that time, don't take stress regarding that particular question whatever you are not getting. Definitely you will lose there. So presentation is very very important. Whatever you learn, that is secondary. Okay, so like that, read the given statements properly first, slowly, with patience, with patience, not like a patient. Next, fourth point. Now, what is the nature of EMF induced in this connection always? There is delta on one side. Yes, the EMF always sinusoidal. Write that point. The EMF induced in this transformer, the EMF induced in this connection is always sinusoidal. In this connection is always sinusoidal. Now, is this connection suitable for single phase load? No, because delta is on secondary, neutral not available, single phase load may not be possible. So only for three phase load, this connection is suitable, right? It is suitable for three phase loads only, because neutral is not available on secondary. Okay, and one more is, it is best suitable for what? Oh, right here itself, comma, suitable for step down applications. Suitable for step down applications. See, if you want to step down a very high voltage to very low voltage, then we can go with star delta transformer, because by nature of this connection itself, it is giving low voltage on secondary. V1 by root 3, 0.577 only we got, no? So very low voltage it is producing. Then we can use a star delta for step down application. Okay. So with this, we complete three-phase transformer, main four connections. Then we have special connections. So before that, you will see some numericals on this three-phase transformer first. And after break, take break now. So after break, I will give note. That is the voltage relation in all the four connections at one page. So after break, we will see all this. Take break. See the next question. See this. Two single phase, two three phase transformers are realized using single phase transformers as shown in figure. So there are two three phase transformers. One is see, this is a delta delta. This is one transformer, three phase delta delta, and this is a delta star. Delta star. Now we have to tell here the phase difference between the voltages V1 and V2. This is V1. This is what? Line voltage. Line voltage of secondary of delta delta. This is V2. Line voltage of secondary of delta star. What is the angle between this V1 and this V2? So for that, you should know this is a delta delta, which vector group first, and this is a delta star, which vector group first. And if you know the vector groups, the angle between these two you can tell easily. Tell me first, this is delta delta, only two we have, 0 degree, 180 degree. Which angle it is? First one, 0 or 180? 0 degree, no. This is a 0 degree connection. Or 12 o'clock connection it is. DD12 it is. Why DD12? Same terminals are the outcome terminals on both primary and secondary. See, primary side A2, B2, C2. Secondary also A2, B2, C2. Okay, 0 degree connection. Same means 0, opposite means 180. So already I given yesterday this statement. Now 0 degree or DD12. How to represent that DD12? Like this. DD12. Capital A pointing 12 and small a also pointing 12. This is 12 o'clock connection. Small a means what? Secondary line voltage. Small a is the secondary line voltage. Capital A is the primary line voltage. LV phasor, HV phasor. Okay, that means that this small a capital A indicates secondary line voltage, primary line voltage. Now this is the 12 o'clock. Like that, delta star, what is this phasor group? First you need to find that. Find this. Yes, right. 30 degrees is correct. Good. 30 degrees is the answer. This is delta star. What is the vector group? If you compare our previous figures, you can directly write. Otherwise, if it is required to calculate the vector group, primary delta. A2, B2, C2 are the source. Okay. So A1, A2, B1, B2, C1, C2. A phase, B phase, C phase. So directly I'm drawing vector group. Secondary star A1, B1, C1 started on secondary. So this is neutral. A1 it is. Now A2 should be in this direction. This is A1, A2 parallel to primary A phase. And from the same point B1, B2 parallel to primary. Okay, next C1, C2, C phase. Now draw the internal star for primary delta. Then what are the internal ABC? That depends on vertices. Which vertices we have to take? Whatever source terminals A2, B2, C2 are the source terminals. So that is we circle. So A here, B here, C here. Now take a clock. Capital A pointing. Capital A pointing 12. Now very small a, if you coincide these two neutrals, small a is pointing 1. This is 12, 1 o'clock connection it is. So this is delta star dy1 connection it is. This is. Now we have to find angle between this V1, delta delta secondary line voltage, delta star secondary line voltage V1 V2 they given. V1 V2 means small a of this, small a of this, small a of this. So this is DD 0 degree connection, this is DY1 connection. What is angle between these two? Directly 30 degrees. So answer is the angle between V1 V2 is 30 degrees. Lagging or lagging, they are not asking, just they are asking what is the angle between these two, V1 V2. Okay. 30 degrees is the answer. What is wrong in delta? Yes. Yes. You identified, good. So anyhow, okay, delta, there is a mistake here because see, A1 is connected with B2 now. In the figure, A1 is connected with B2. A1, this is A1, so B2 should be here. B2 should be here. Check it once. That you should identify. Observe primary delta A2, A1. A1 connected with B2. So from here B2, A1, B2, B1. B1 connected with C2, C2, C1. So A phase, B phase, C phase. Next, drawing small, that is A1, A2, small a, A1, B1, C1. This is A1, A2 is in this direction. This is A1, A2, A phase. Okay. Next, from this B1, B2. This is B1, B2 in this direction. B1, B2. Next, C1, C2. C1, C2, C phase. Okay. Now draw the internal star in delta. This is internal star. Now outcomes are A2, B2, C2. Circle A2, B2, C2. Then internally, this is A phase, B phase, C phase. Now take a clock. Now place here. Capital A pointing 12, but very small a, if you coincide these two neutrals, primary reference star and this star, small a will come exactly here. But anyhow, we are getting 30 degrees only, but it is 11 o'clock. Previously we said that is 1, that is 1 is wrong, 11 is correct. This is 11 o'clock. YD 11 it is. DY 11. DY 11 it is. Primary delta secondary star DY 11. Now what is the angle between these two? 12 o'clock, 11 o'clock. So angle is one digit of 30 degrees. 30 degrees only, right? Okay, clear all of you this? Good. 30-degree lead it is. DY11 means 30-degree lead. Secondary phase A leading primary phase. If they ask about lagging or leading, how to say? See, delta delta secondary voltage V1. Secondary voltage means secondary phasor A here, small a. This small a. So this is small a. I am drawing directly small a. And for other transformer, small a we got here. Now observe, this is V1 according to their notation. This is secondary line voltage V1. This is secondary line voltage of other transformer. Now which one is leading here in vectorial direction? V2 leads V1 by 30 degrees. If they ask particularly whether it is lagging or leading, then this is correct. Or you can say V1 lags V2 by 30. Anything you can consider. Okay. V2 line voltage they mentioned in the question. See, what is they indicated? Observe the question. V1, V2 are the line voltages or not? Yes, line, because between two terminals they are asking line voltage it is. Anyhow, directly also we can get DD0 or DD12, DY11. Angle between these two is 30 degrees directly. They are asking only angle in this question. Next question. Completed all of this. So who said V1 is phase voltage? V1 also line. Check the figure. Between two lines, what is the voltage we call line? No, that is, this is delta and this is star. Between two terminals, that is a line voltage. Phase voltage means what? This is phase voltage. If they given here, now it is V2 is phase voltage. Okay. So observe properly. Next question. See this question. For this question, you no need to draw that vector groups directly. You can answer with respect to the winding diagram they given directly. Try this. What is the answer? Tell me. What is the answer? Easy one it is. No need to draw vector groups directly. You can consider the winding itself. See, this is phase A, this is phase B, this is phase C. Actually, see, question is, if the start side of star delta transformer shown in figure is excited by a negative sequence voltage. Positive sequence means what? In clockwise, what is the sequence we are getting in the winding diagram? Always A, B, C. Okay, but observe here, in anti-clockwise you will get A, B, C. That is negative sequence. So whatever the sequence, both are same only. Whatever you give to primary, same will come on secondary also. Okay, they given negative sequence. That is in clockwise ACB or anti-clockwise ABC. Actually, in all our diagrams, we are drawing positive sequence. In clockwise direction, you will get the sequence like A, B, C like this. But here negative it is. Okay. Now, anyhow, directly I am drawing phasors. See, this winding representation directly they given. This is A phase on primary. This is A phase on secondary. This is B phase on primary. The corresponding, see, both in phase. This is B phase on secondary. See, anti-clockwise direction ABC. This is C phase. Parallel, this C phase parallel. Okay. So directly I am drawing. First, in star, what is the phase voltage? Phase voltage, line voltage different or not? Yes. But in delta, phase voltage, line voltage same only. So first I am drawing phase voltage relation, phasors. Phase voltage phasors I am drawing. Observe. Primary side star. Let it is VA. Okay. Next. In negative sequence, that's why I'm going in anti-clockwise direction here. Negative sequence. This is VB. 120 degrees. Next VC. Okay. VC. Negative sequence. Positive sequence means VB here. Okay. This is the primary star connection. So in the same, however winding they given, in the same way I drawn these phasors also. Next, secondary delta. Secondary delta we have to draw. But in delta, phase voltage, line voltage, both are same. Okay. So phase voltage, this is VA or VAB. VAB or VA, both are same. Line voltage, phase voltage, both are same. That's why I'm starting. I will take reference of this diagram. So parallel to this only I have to draw that. See, this is parallel to this primary phase A. I am drawing. This is VAB. Both in phase. Phase voltages of both in phase. VAB. VAB why I am calling? Because line voltage, phase voltage both are same in delta. So directly it is a phase voltage and also line voltage. Next, VBC. VBC. Next, VCA. VCA. So these are phase voltage relations on primary and secondary phase voltages. Now in delta, line voltage, phase voltage same, but in star, what is the VAB means? What is VAB in star? VAB in star is what? VAN minus VBN only, no? VAB equal to VAN minus VBN in star. That's why this is VA in star minus VBN. Where is minus VBN? So this is VB. VBN or VB both are same. So N they are not taking. So no, don't consider N. Otherwise consider N here. This is VAN. This is VCN. Whether you indicated N or not, no matter. That is phase voltage only. Now what is the line voltage? VAB. So this is we have to draw. VAN minus VBN. So this is VAN. Now where is minus VBN? Oh, this is VBN. No. Minus means take exactly opposite. This is minus VBN. Now resultant of these two we call VAB. Resultant means how to draw? Draw a line parallel to VBN and from here draw a line parallel to VAN. The intersecting point of these two we call VAB. This is VAB. Okay. Line voltage, line voltage. So they are asking in the options VAB and VAB. In every option VAB, VAB. VAB means line voltage. VAB means line voltage. Now we have the primary line voltage. We have the secondary line voltage. Tell what is angle between these two? 30 degrees. Because this angle 60 and this angle how much? 30. Okay. This VAN, this VAB both exactly parallel in phase. So if you take these two neutrals and coincide each other, if you coincide these two neutrals, then you will get exactly, see, if you coincide, this is VAB and this is capital VAB. Now observe these two vectors. In vectorial direction, who is leading or who is lagging? So you have to check options for this properly. This angle is 30 degrees only, no doubt. This angle is 30 degrees, but who is leading or lagging? Based on the options, you have to answer this. So here, small VAB leads capital VAB by 30 degrees. This is one method. Or other way we can say capital VAB lags small VAB by 30 degrees. Anyone correct. But observe option what they are asking. They are asking with respect to capital VAB. Lags small VAB by 30 degrees. Option D is right. Okay. Now only this method. Only this method you have to follow. First draw primary phase A, secondary phase A, both in phase. Okay, both in phase. Now based on the connection, we are considering line voltages. If it is star, line voltage is what? This is VAB equal to VAN minus VBN. But if it is delta, the line voltage, phase voltage, both are same. So actually we consider phase, that is itself line here, both in phase. Primary phase voltage, secondary phase voltage, both in phase. But if you consider line of both, then angle we are getting 30 degrees. Okay. Dots no significance, but terminal names they did not mention which terminals they taken outside like that. Particularly for delta star, you can identify this is A2, A1, A2. A2 is outcome, but delta side, this is A1, this is A2, and here like that A1, A2, this is B1, this is B2. Actually, the given dots is wrong in this. Dot polarity given is wrong, because how to connect a delta properly? Dot should connect with undot. Dot should connect with undot. Dot should connect with undot. This dot, I think printing mistake, it should be here. Then A1, A2, B1, B2, and here C1, C2. Then which is the outcome in this? That is not mentioned properly. Okay. And you can consider another way, as A is mentioned here, A2 is the outcome. Okay. So these are all not required. Don't confuse again. Just draw the both phases in phase first and then check line voltages enough. You will get easily. Why we take primary, secondary in phase? For all connections, same thing we are following now up to now. We are drawing primary phase A. Drawing secondary phase A also exactly parallel in phase with that. Same thing we followed here also. Otherwise, if you have doubt like this, you proceed as it is like previous connection. Same answer you will get. Okay. Next question. Answer this question. What is answer? Which three-phase connection can be used in a transformer to introduce a phase difference of 30 degrees between its output and corresponding input line voltages? See, whatever the angles we have, like that previous connections, 30 degrees, 150, these are all what angle between line voltages only, primary line voltage, secondary line voltages, remember. Now 30 degrees angle in which connections you are getting? Which connections you are getting? So still we have not seen this. I will tell about this delta zigzag star. We have seen remaining. So totally we have delta delta, star star, previous delta star, star delta. Out of these four, delta delta star star will give similar vector groups, 0 degree, 180 degree. Delta star and star delta will give that plus or minus 30, 180 plus or minus 30. Four groups, plus 30 one group, minus 30 one group, 180 plus 30 2 times, 180 minus 30 150. Total four vector groups. Okay. Now where we are getting 30 degrees? In delta star we are getting, star delta also we are getting. Okay. So in the options, delta delta star star, here you will get only 0 degree, 180 degree. You never get 30 degrees. So this is wrong. And delta zigzag star, presently you don't know what type of vector group it will give. It will also give 0 degree, 180 degree. Okay. Only star delta will give 30 degrees. So option B is correct. So we will see delta zigzag star. What type of vector groups we get in delta zigzag star, I will show you. Next. Next question. Okay. Before this question, make a note regarding three-phase voltages. Make a note. Note. So here I will give for all connections. Connection. connection. Then line voltage relations, line voltages, primary, secondary line voltage relations I will give here, and line turns ratio, line turns ratio. So these are we are getting in examinations. These three we will see here for all connections. First one, first delta delta. So in delta delta, if you apply a voltage V1 primary side line voltage, how much voltage you are getting secondary side? V1 by X you are getting. V1 by X you are getting on secondary side. So if you V1 gets cancelled, finally what is the line turns ratio you get? X is to 1. Don't confuse here. Actually X is to 1 we call phase turns ratio it is. Phase turns ratio. X is to 1 means phase turns ratio. Then what is the line turns ratio also we are getting? Same we are getting for delta delta. Like that, second star star. What is the voltage relation in star star also? Same. V1 by X. Here also V1 cancel and you will get X is to 1 only. If the phase turns ratio is X is to 1, line turns also same. Line turns ratio also same for delta delta and star star. But for remaining two connection it will change. Observe delta star. What is the relation? If you apply a voltage V1, how much voltage we got there? Root 3 V1 by X. This much voltage we got. Then if you cancel this, V1 gets cancelled. Finally, what is the turns ratio we get? X is to root 3. Important. For competitive examination, direct questions here. If X is to 1 is the phase turns ratio, then in delta star connection, what is the line turns ratio? The line turns ratio is this, X is to root 3. Okay. Line turns ratio. Similarly for fourth connection, star delta. What is the relation voltage? If you apply V1, how much voltage you got on secondary side? V1 by X root 3 we got. Then V1 cancel. What is the ratio finally? X root 3 is to 1. This is the line turns ratio for star delta. Remember these ratios. These are voltage relations, primary, secondary, and this is line turns ratio. Whenever they ask line turns ratio, you should give these answers. Okay. So how they will give is example. See, a three-phase delta delta transformer having a phase turns ratio of 2 is to 1. A phase turns ratio of 2 is to 1. Then what is the line turns ratio? 2 is to 1 only for delta delta. Suppose they given in a three-phase delta delta transformer, the phase turns ratio is 2 is to 1. Then line turns ratio is dash. Answer is 2 is to 1 only. Same it is. Okay. So for example, they asked in a delta star transformer, in a delta star transformer, phase turns ratio is 2 is to 1. Then what is the line turns ratio? Tell me. What is the line turns ratio? 2 is to root 3. This is the line turns ratio. Okay. Just X is to 1 is the phase turns ratio. Observe, X is to 1 is the phase turns ratio. X is to root 3 is the line turns ratio. Here also, in place of X, we have 2. 2 is to 1 is the phase turns ratio. Now 2 is to root 3 is the line turns ratio. Remember this. Okay. All angles 30 degrees, that 180 degrees, all angles whatever we have seen in previous connections, all the angles between line voltages, primary line voltage, secondary line voltage. Okay, remember this type of questions. If you remember this table enough for all connections, directly you can answer. Whatever the phase turns ratio they given, answer is accordingly this line turns ratio. Okay. How can turns ratio is decimals? Decimals means turns ratio may be anything, because primary side 100 turns, secondary side 150 turns. Then what is the turns ratio? 100 by 150. How much it is? Oh, whatever you get, that is x is to 1. It is the phase turns ratio. Then what is the line turns ratio? That you need to calculate. Okay. Any ratio may be possible. Turns may be any value. No, there is no fixed value. Only turns should be like this. Okay. Yes, turns may be fraction also. Turns may be fraction also. So follow the numerical. We are not doing practical now here. Follow the numerical, whatever it is. See this question. So this is the question on three-phase transformer and induction motor. Question related to three-phase transformer and induction motor. Read the question first. Read the question. A 50 HP 440 volt three-phase induction motor with an efficiency of zero point 0.9 and power factor of 0.85 on full load, supplied from a 6600 by 440 volt delta star transformer. Okay, ignoring magnetizing current, we need to find the currents in the high and low voltage transformer phases when the motor is running at full load condition. Question is nothing, but we feel difficulty in this. Based on the question, try to draw the figure. So induction motor is there, three-phase induction motor. For that three-phase induction motor, who will give supply? Transformer will give supply. That is the secondary or output of transformer we are giving to induction motor as a input. So this is the figure. There is a transformer connection is what? Delta star. The transformer is delta star connected like this. Primary delta, primary side delta connection, and secondary side star connection. Delta star transformer. Now this transformer will give supply to induction motor. Let this is our induction motor. It is supplying power to induction motor. Okay, supply given to induction motor from this three-phase transformer. What is the input rating of transformer? 6600 primary side line voltage, and 440 volts is the secondary side line voltage. 440 volts. Okay, what we need to calculate, and given that induction motor having efficiency, this is the shaft power of induction motor. So in every motor, maybe DC motor or induction motor or synchronous motor, any motor, which power we will take outside always? Shaft only we take outside. Shaft power. So given 50 HP, what is that 50 HP indicates in the motor? Horsepower or mechanical power of motor is that much. So given that this is the output of motor, which is 50 HP. What is 1 HP? 1 HP, 746 watts, no? 746. So this is our output power given in the motor, and efficiency of motor also given. How much? 0.9. Once you know efficiency and output, you can find input or not. Yes. What is efficiency first? Output power by input power of the motor. Output power we know already, and then input power you can find. Once you know input of motor, this input of motor nothing but output of transformer only. Yes, both are same. Motor input, transformer output, Same or not? Yes, same. Motor input, transformer output, both are same. So we need to calculate here currents in the high voltage and low voltage transformer phases. We need to find I2 phase and we need to find I1 phase. Okay. Anyhow, star connection means phase current, line current, both are same. Phase current, line current, both are same. Delta connection, phase current is different. This is line current. This is line. This is phase. So we need to find the phase currents. So simple question. First, calculate what is the input of motor. Efficiency is there, output is there, find input. Okay. Take the figure first. Take the figure. Now find input of induction motor. See, given that efficiency of motor is output of motor by input of motor. We have output, we have efficiency, input we can find. Input equal to output of motor by efficiency of motor. What is the output of motor? 50 HP. 50 into 746. 1 HP is 746 watts. That's why I'm writing that. 1 HP is 746 watts. Okay, divided by efficiency given 0.9. Then what is the input of motor? Input power of motor is, calculate how much? 50 into 746 divided by 0.9. So this is 41444.4. Okay, this is input power. So all of you got same, no? Yes. Now this is the input power of motor. And how to write this input power of motor in terms of equation? Power, na, it is active power, VI cos phi. But as it is three phase, what is the formula of power in three phase? 3 V phase I phase cos phi. Or one more formula given previously. What is that? Root 3 VL IL cos phi. Okay. Root 3 line voltage, line current, power factor. If it is only volt ampere, we don't write cos phi, but it is watts, no, power in watts, active power it is. That's why VI cos phi. Therefore, 41444.4 equal to root 3. This is line voltage. Which line voltage? This is only, no. This is V2 of secondary line voltage of transformer. That is input to motor. Both are same. So that is 400, 440. This is 440. 440 into current. What is the current drawn by motor? See, current drawn by motor is IL. IL or I2, both are same. Transformer secondary current, nothing but input of motor, both are same. So I'm writing directly I2 cos phi. Cos phi also there. What is the cos phi value? It is operating at a power factor of 0.85 given in the question. Substitute here into 0.85. Calculate the current I2 from this. How much? Current I2 how much? Yes, 63.97. Right, 63.97 ampere, approximately 64 amperes. Okay, this is the secondary line current. Line current from the equation always you get from this. But as secondary star connected, what is the phase current? Also same. Phase current, line current, both are same. Clear? This is secondary phase current. And what we have to find? One more, primary phase current we need to calculate. Secondary phase current we calculated now. Now we need primary phase current. What is the formula? Therefore, I1 phase by I2 phase. What is the formula in terms of voltages? E2 phase by E1 phase. I1 by I2 equal to E2 by E1, no transformation ratio, both equated. Now calculate I1 from this. I1 phase equal to 64 into what is the secondary phase voltage? Secondary means star. Line voltage 440. Phase voltage is 440 by root 3 divided by primary phase voltage. Primary connection is what? Delta. What is the voltage given here? 6600. It is line. Phase voltage also same for delta. That's why 6600. Calculate how much? What is the phase current primary? Primary phase current. How much? Yes. 2.4. Yes, right. Right. 2.46. 2.46 amperes. This is our primary phase current, I1 phase. So I1 phase is this, I2 phase is this, 2.46 and 64. So from given options, this is option A is right. Option A is correct. So clear how to solve this? Nothing difficult here, no difficulty. Only the thing is you should know the procedure. They given induction motor efficiency and output power of motor also given. So using that we calculated input power of motor. Input power of motor is nothing but transformer output only. Now transformer output is secondary side. So using that current we calculated, that is itself secondary current of transformer. That is we got. Once you know secondary current, primary current easily we can find by using that voltage relation. Okay. Clear all of this one? Okay, right. So first we completed the main four transformers connections. Four connections we complete. Now we have special connections in three-phase transformer. Let's see what are that. Setting special connections. Special transformer connection. Right. Special connections in transformer. Special connections in transformers. So one is delta zigzag star. Second, star zigzag star. Third, open delta connection. And fourth, Scott connection. Scott connection. Delta zigzag star, star zigzag star, and open delta Scott connection. See, particularly out of these four, this Scott connection is not there in gate examination. For gate examination, there is no Scott connection. Only for engineering service and all other competitive examinations, you will have Scott connection. Okay. For gate, we don't have Scott connection. That's why I will give the information only up to required for prelims examination point of view, but I'm not giving complete information of this Scott connection right now. So once those who join for only main ESC engineering services, we will have again after completion of your prelims examination or after gate examination next year, again you have mains classes. So there we will see the complete details and questions on the Scott connection. Conventional questions, very big questions there are. So Scott connection only for prelims we will see here. Okay. And remaining these three are there for all examinations, gate, ESC and PSUs. Okay. But one more thing, for any examination, particularly for GATE and competitive examinations, we should know what is delta zigzag star, what is star zigzag star. That's it. You should know what connection or what vector group you will get. That's it. And you don't get any question other than that from these two connections. These are special connections. In the syllabus also it is they never mentioned particularly, but still we are learning because just now we have seen one question previously. This one. Here they given delta zigzag star. If you don't know about this delta zigzag star, then we cannot answer this question. Okay, for engineering services and for GATE also this type of questions we have, because we have the next topic is like parallel operation of transformers. Parallel operation. So in order to operate two transformers in parallel, they should have same vector group. For that they will give in the option this one also. So for that reason you should know about delta zigzag star, what vector group is possible using delta zigzag star. Okay, so for that reason I will give one connection in delta zigzag star and I will show one connection in star zigzag star. What vector groups are possible in this? Okay, and open delta we will see clearly again. Now first of all, what is this zigzag star? What is the need of that zigzag? Yes, the zigzag star, the main purpose of zigzag star is, previously we have one connection star star. Star star connection is there. Okay, in this connection what is the problem for us? Only for shell type core previously we got one problem. The shape of EMF induced is what? Peaky wave. The shape of EMF induced peaky wave, that is each phase is having two voltages, fundamental plus third harmonic. Due to this we cannot connect single phase loads. Okay, for that, in order to make this EMF sinusoidal, previously what are the methods we used? In yesterday's class I given two methods. One method is by providing neutral grounding, that is one method, and second method is by providing tertiary winding, that is second method. Now the third method is zigzag star. The other method, in order to make that EMF per phase also sinusoidal, the other method is zigzag star. Okay, now I will give the information about only zigzag star first, then we go to connections. Right here, right now, zigzag star, side heading, zigzag star, zigzag. So in the name itself, why it is zigzag we call, so I will show you in the figure. See, actually delta zigzag star not required. Delta zigzag star, there is no use of the delta zigzag star, because delta star any problem? No problem. Problem for what? Star star. Then only we need this star as zigzag star. Okay, anyhow they given delta zigzag star also, they given what type of vector group possible with delta zigzag star. That's it. Only star zigzag star we will utilize. We don't utilize delta zigzag star. No need of delta zigzag star. Only star zigzag star we need. Right, zigzag star. First let's see normal star, then we go to zigzag star. So write quickly normal star. In normal star I am taking only secondary side. Okay, secondary side only I am drawing. Secondary side only I am drawing, not primary star. Secondary side, this is small a, small d, small c, polarities A1, A2, B1, B2, C1, C2. Now observe, this is our normal star only. No, this is called normal star. Now when there is a star star connection, what is EMF induced in each phase? Peaky wave. Shell type I'm talking about shell type code. So the EMF induced is peaky, means in each phase, A phase, B phase, C phase, we have fundamental EMF plus third harmonic EMF. Fundamental EMF, third harmonic EMF. E1 plus E3. Three phases. Angle is one at, this is at an angle 0. This is at an angle minus 120. This is at an angle minus 240. Okay, three phases, 120-degree displacement. And what is the third harmonic angle? 0 always. 0, 0. So in normal star-star transformer, the EMF induced per phase is peaky wave, that is having both fundamental and third harmonic. That is I written here first. Then can you connect single phase load? What is, some people asked previously, I think, what is single phase load? What is three phase load? How it is? Single phase load means what? We will connect one load between phase and neutral wire. That is single phase load. And three phase load is what? That is connected between across A2, B2, C2. This is three phase load. Okay. Now problem is what? Because of phase EMF, line voltage is no problem. Line voltage, three phase load you can connect, no problem. But problem is for single phase load, because in each phase we have E1 plus E3. This single phase load, if you connect, loads will damage because of that harmonic, third harmonic voltage. So normal star is not suitable now. Then in order to make this EMF sinusoidal per phase, previously what are the methods we used? Neutral is grounded, one method. And second method, tertiary winding, delta connected winding we used in that star-star transformer, second method. Now the other method is this zigzag star. Now see here, what we do in zigzag star is, each phase we will divide into two equal parts. See, like this, A by 2, A by 2. A phase only in two parts I will divide equally, 50 turns, 50 turns, for example, like that. Similarly, B phase, B by 2, B by 2. Similarly, C phase, C by 2, C by 2. I will made, that is each phase is made into two equal halves. Okay. Now you need to conduct polarity test again. This is what, A by 2, A by 2. This is also A by 2, B by 2, B by 2, C by 2, C by 2. Two equal halves. Now conduct polarity test for each half first. Suppose for this polarity test is conducted. Here we got polarities. And again conduct polarity test separately for this part. Here we got polarities. Now mark the terminals. How to mark terminals? A1 dotted terminal always even number, A2. This is A3. This is A4. Similarly, B1, B2, B3, B4, C1, C2, C3, C4. Terminals marked. Now short any three similar terminals. A1, B1, C1 or A2, B2, C2 or A3, B3, C3, any three you can short as in neutral point. Now I will take A1, B1, C1. This is our neutral in this star. Okay. Now interconnect. We have to interconnect this. How? With series subtractive polarity. Means this is the dotted terminal A2. Here B4 is the dotted terminal. So join similar polarities. A2, B4. Similarly, B2, C4. Next, C2, A4. This is a star connection, not delta. It is star only. It is. Check. Go from one end to other end. You will get neutral. A3, A4, C2, C1. Star only it is. But it is called interstar connection or zigzag star connection. This is also called interstar. Interstar connection. Each phase is interconnected by two phases. So actually here A phase, this is normal star, A phase, B phase, C phase, only one phase. But here each phase is having half A phase, half B phase, half B phase, half C phase, half C phase, half A phase. This is called interstar connection. Now why we are using this? Yes, to eliminate the third harmonic. How it will eliminate? Check now how it will eliminate here. Interesting. Observe how it will eliminate is, I will show you. Observe carefully. See now. In A phase, E1 plus E3. Okay. Similarly, here I will write E1 by 2, E1 by 2 at an angle 0 plus E3 by 2 at an angle 0. Clear all of you why I written half? Because half of the turns. and remaining here is there E1 by 2 at an angle 0 plus E3 by 2 at an angle 0. Clear? Why I written half? Because half of the turns, half of it will divide. Similarly, write for B phase. If you have confusion, take another figure, don't write here itself, or remove that A by 2, B by 2, then write. Remove this A by 2, B by 2 here. Now write only these magnitudes. Next, in B phase, E1 by 2 fundamental plus third harmonic. E1 by 2 at an angle minus 120. B phase, no, it is. A phase is 0, B phase is after 120 degrees. Plus E3 by 2 at an angle 0. And for this half, E1 by 2 at an angle minus 120 plus E3 by 2 at an angle 0. Okay. Third harmonic is always 0 sequence. And fundamentals displaced by 120 degrees. That is I'm writing. Similarly for C phase, E1 by 2 at an angle minus 240 plus E3 by 2 at an angle 0. Similarly for C phase, E1 by 2 at an angle minus 240 plus E3 by 2 at an angle 0. However, is there in normal star, same values I am writing again in zigzag star, but half of, okay, half of, because equally we divide in two parts, now that is clear. Now where you will connect load here in zigzag star. So here we are connecting load across A2, B2, C2. Like that, where we will connect, see which are the end terminals here. Which are the end terminals? A3, B3, C3 are the end terminals. So let us take any one end. Suppose take B3. Take B3. Now come from B3 towards up to neutral. This is our neutral point now. So I need VB3N. This is one phase voltage. Like that, VA3N neutral, one phase voltage. VC32N, one phase voltage. Now try to find VB3N first. VB3N. Go from B3. See, E1 by 2. This is E1 by 2 at an angle minus 120 plus E3 by 2 at an angle 0. Okay, this part I written. B3, B2 I written. Next, A2, A1 is there. But how we connected polarity check? Dot is joined with dot. So subtraction or addition? Subtractive it is, minus. We have to connect subtractive only. Then only it will work. Otherwise, no use of the taking. Why I will show you, just listen now. Minus. Why minus? Subtraction. Subtractive polarity we connected now, dot with dot. Next, minus E1 by 2 at an angle 0 plus E3 by 2 at an angle 0. Okay. Go from B3 to N. N means this A1, B1, C1 is N only. B3, B4, A2, A1. That's it. These voltages minus these voltages. Now, if you check here, E3 by 2 gets cancelled. It will get cancelled. Minus, minus, that is plus, minus here, cancelled. And finally, what is left remaining? E1 by 2 at an angle minus 120 minus E1 by 2 at an angle 0. Only fundamental is left in this phase voltage. Only fundamental is left. Is there any third harmonic in this? No, cancelled. Why cancelled? Because you connected subtractive polarity. Because of that only we are connecting subtraction. Otherwise, if you connect dot with undot here, again additive, E3 will be there still. It won't eliminate. In order to eliminate the third harmonic, we are connecting subtractive polarity, zigzag, zigzag. Okay. Finally, find how much voltage it is. VB3 and how much? Calculate once. 0.5 at an angle minus 120 minus 0.5 at an angle 0. This is its magnitude 0.866 at an angle minus 150 E1. Okay, this much 0.866 E1 at an angle minus 150. Okay, this is the fundamental voltage. phase voltage is this. Not only VB3N, you find VA3N, then also you'll get same value 0.866 even only magnitude, angle some value will get VC3N. This is also you'll get same 0.866 even only, check if you want. Okay, in all phase voltages now only fundamental is there, no third harmonic. Now can you connect single phase load or not? Yes, you can connect, no problem. Problem of third harmonic eliminated. That is the purpose of zigzag star. Clear why we are using zigzag star? To eliminate third harmonic in phase voltages also. Okay, to eliminate third harmonics in phase voltages we are using zigzag star. Clear all of you this? Yes, good observation. Good observation. The advantage of zigzag star is what? The third harmonics are eliminated in each phase. But observe here, what is the phase voltage? VA to N. What is the phase voltage? E1 plus E3. Both are there. Both are there. But if you take only fundamental here, what is the magnitude of that voltage? E1. Similarly, what is VB to N? E1 plus E3. Both are there. So when there is third harmonic in any phase voltage, you should not connect single phase load. But in this, is there any third harmonic here? No third harmonic. Only fundamental is there. But what is the drawback of zigzag star? Yes, the drawback is in actual normal star connection, the fundamental voltage is E1. But what is the voltage we are getting? 0.866 E1. Some fundamental voltage reduces or not? Yes. Some small fundamental voltage reduces. How much reduces? 13.4 percentage fundamental voltage reduces. This is drawback for us. Some voltage magnitude is reduced in zigzag. But advantage is what? Third harmonic EMF is eliminated. Third harmonic eliminated. Okay. So what is the advantage over normal star? Third harmonics are eliminated in each phase, so it is suitable for single phase loads. But drawback of this zigzag star is small fundamental voltages reduce compared to normal star connection. Okay, write these points. Clear now? Write these points. Right here. First point. In normal star, the phase voltage is having both fundamental and third harmonic, both fundamental and third harmonic EMF. Hence it is not suitable for single phase loads. Not suitable for single phase loads. Next, second. In zigzag star, the phase voltage is free from third harmonics, third harmonic EMF, comma, it is having only fundamental. Hence it is suitable for single phase loads. Now you can connect single phase load to zigzag star. However, previously in neutral grounding method, EMF is sinusoidal. Here also EMF is sinusoidal. But drawback of this zigzag star is what? Some small fundamental voltage reduces, because you are getting 0.866 E1, but not E1 like previous normal star. Okay, normal star voltage E1. but now you got 0.866 even. Some voltage reduces. Write that note. Make a note. Note. In zigzag star, in zigzag star, a small a small voltage drop or a small voltage, all right, in zigzag star, the fundamental voltage is reduced. The fundamental voltage is reduced. So how much reduces? 13.4% reduces compared to normal star. 13.4% voltage reduces compared to normal star. Clear all of you these points? Yes, delta star advantage. Delta star is advantage. So these are the methods. If you want to make EMF sinusoidal in star star also, we have to use zigzag star. One of the method is this one, zigzag star. Now let's see one connection. Delta zigzag star, one connection. Star zigzag star, one connection. Only one connection we will draw here, just to know this is giving which vector group. Okay, listen, same as it is previous connection, but little care required while drawing this delta zigzag star particularly. Let's see that first one, delta zigzag star. Delta zigzag star. Delta zigzag star. Same procedure. Take the primary three phases connected in delta. Yes, we need the right. As some fundamental voltage reduces in zigzag star, no? Now you need to increase some number of turns there so that you will get even again. Compared to star star, del star zigzag star required little more number of turns because some voltage is drop, fundamental voltage reduces. So to maintain the same voltage E1, you need more number of turns now. Okay, little cost increases for zigzag star. Primary side, three phases connected in delta. Secondary side, three phases only, but how to take zigzag star? Two halves. Half of A phase, A phase. Half of B phase, half B phase. Remaining half C phase, C phase. Okay. Primary side ABC. Primary no change, same connection like previous. But here half of you have to take A by 2, A by 2, B by 2, B by 2, C by 2, C by 2. Now conduct polarity test individually for each half. Primary side A by 2. Do the polarity test and mark the polarities. Similarly for again this primary A and this A by 2, do the polarity test, mark the polarity. Like this we need to mark polarity for all. Next step, terminal marking. A1, A2, A3, A4. This is A1, B1, C1, A2, B2, C2. Same marking. The dotted terminal always we indicate with even number. Remember this. C1, C2, C3, C4. Okay. Now make the connection. Primary delta. Delta A1, B2, B1, C2, C1, A2. Primary delta. Secondary zigzag star. So short any three A1, B1, C1. Now how to connect remaining? Subtractive. Dot should connect with dot. Dot should connect with dot. Okay, dot connected with dot. Subtraction only there. Otherwise, third harmonic will not eliminate. Now, which vector group it is? That is our main aim here to find which vector group. Suppose we don't know this is giving 0 or 180 or 1 5 7 11. Which vector group possible? 0 180 is given by two connections already. Which two they are? Delta delta star star. 1 5 7 11 given by two connections. Which two they are? Delta star star delta. Now let's check these two connections also, which vector group we get. Now see the procedure. Completed this diagram, all of you? Completed? See now. Primary delta, same as it is like previous draw. See, A2, B2, C2 taking outside, source is connected here. Source. And secondary side, which three are now outside? Observe, A3, B3, C3. Here we connect load. Across these three, we will connect load. A3, B3, C3. Primary side, A2, B2, C2. Source is connected to this. Now observe, A2, A1, A2, A1. Now observe the figure. A1 is connected with B2. A1 is connected with B2. Same, A1 connected with B2. B2, this is B1. B phase. A phase. B1 connected with C2. C2, C1, C phase. Primary delta, same as it is previous connection. There is no change in this. Next, secondary is zigzag star. This is little carefully we have to draw. Okay. So I will tell now why we call zigzag it is, or interstar. Interstar means between two phases interlink, A, B, B, C, C, A. Interstar it is. And why we call zigzag? The shape looks like zigzag. Zigzag. So if you remember, in which game, one of the sports we have zigzag run, that is Coco. Zigzag run. Like this we run now in that zigzag. Same as it is, this star also looks like. That's why they name it is zigzag. Let's see that. Which are shorted here? A1, B1, C1 shorted. Means neutral is A1, B1, C1. Neutral point is A1, B1, C1. This is A1. Now I have to draw. How to draw here is C. First you have to take, start from A1. Start from A1. A1, A2. First is A1, A2. Next, continue B4, B3. Start from neutral. Start from neutral. These are all neutral points. Neutral points. Same only. Start from neutral and go towards the end of the terminal B3. Again start from B1, go end of the terminal C3, like that. So first here A1, A2 we have to draw. Okay, A1, A2. First I have to draw from, this is A1, then A2 in which direction? Observe primary side. Observe primary side. A phase parallel to primary. This is A1, this is A2. Okay, A1, A2 same as it is primary I draw. Same, this is parallel in phase. Next, check A1, A2 over. Next, what is there? B4, B3. B4, B3. Okay. Next, from A2, this is B4 point. Now B3 I have to draw. So totally B phase should be parallel to primary B phase. So if it is B4, where is B3? Towards right or left? If it is B4, you should draw towards this. This is B4 point. A2, B4 same point. Both are connected. A2, B4. This is B3. Because observe here. B4, B3. B4, if you coincide this one, this is B by 2 now. B4, B3, this is B by 2. If you coincide B4, B3 here, B4 should coincide with B2, B3 should coincide with B1, because odd should coincide, even should coincide. Both in phase. How can you say both in phase? Odd should coincide, even should coincide. Like A1, A1, A2, A2. However, A1, A2, A1, A2 coincide. B3, B4, B1, B2 should coincide. Odd number, even number. Okay. Now finally, this is completed. This is neutral. We are moving like this. Next, in the same way, start from B1 now. See, second one, you only should draw star, zigzag, star. Star, zigzag, star, you only should draw. Listen carefully here. Next, start from B1. B1, B2. First is B1, B2. So draw that. This is B1, B2. Now, which direction I have to go? This is B1. B2 should be in this direction. B1, B2. Why? Here B1, B2. If you coincide B1, B2, primary side B1, B2, secondary side B1, B2 coincides each other, both in phase. This is right. Okay. B1, B2. Next, what is there? Check in the diagram. B1, B2. After that, C4, C3 we have. C4, C3. From here, C4 it is. This point itself C4. Now I have to draw C phase parallel to this C. So C4, C3. Okay. See, C phase. This is primary C phase parallel. Even C4, C2 coincide. C1, C3 also coincide. Okay. This is the end of the terminal. Next, one more is left. Start from C1. C1, C2, A4, A3. First draw C1, C2. Okay. From this point, this is C1. Now C2 I have to draw. So I should draw C phase parallel to this primary C phase. Parallel to primary C phase. See, both parallel. C1 it is, C2 it is. Okay, both in phase. Like that I'm drawing both in phase. C1, C2, not upward direction. If you draw upward direction, C1, C2 will not be coincide 180 degrees. So both must be exactly in phase. Next, C1, C2 over. Next is A4, A3. A4 from this is A4. Now A3 I have to draw. How? Observe primary phase A. Parallelly we have to draw A4, A3. This is A4. This is A3. Now check A4, A2 coincide. A1, A3 coincide. Odd, odd, even, even. Now star we got. Observe how this star looks like. This is like a zigzag, no? Zigzag, zigzag. That's why we call zigzag star it is. Normal star is like this. But it is not normal star. It is zigzag. Now important here is how to consider clock connection. Primary side you can consider easily. Just draw internal star. And what are the outcomes? Source connected A2, B2, C2. So A2, B2, C2. A phase, B phase, C phase. This is okay. Secondary side, how to take? Here we have to take resultant. How it is observed. For this is the end of the terminal. Load is connected at B3. Load, observe. B3, A3, B3, C3, load is connected. So circle that. A3, B3, C3. Now take the resultant. Take resultant. This is small a. It is pointing A3, no? A phase. Similarly, it is pointing B3, B phase. It is pointing C3, C phase. This is resultant. Clear? Now take a clock. Take a clock. Okay. Capital A is pointing. Capital A, this one. Pointing 12. And check very small a. If you bring this neutral exactly in phase with this neutral, small a, you will get exactly in the downward direction. Small a, we get exactly downward. Then what is the angle between capital A and small a? This is 180 degrees. So it is 180 degree connection. Or simply we call 6 o'clock connection. Or how we represent DZ6 delta zigzag star. DZ means delta zigzag star, that is 6 o'clock connection. So this delta zigzag star giving the vector group similar to which three-phase transformer? Delta delta star star. Therefore delta delta star star delta zigzag star. These three are same vector group transformer. These three transformers will give same vector groups, 0 degree, 180 degree. Okay. Complete this all of you first. Star zigzag you should draw now. So complete star zigzag also today itself. Yes, all odds should coincide, all even number should coincide. Right. Secondary also positive. A, B, C clockwise only we get, not negativities. So you have to consider resultant phasors. A, B, C clockwise only we are getting. Maybe here while drawing that half of you may get like that, but don't consider that. The resultant is clockwise. A, B, C only. Primary also A, B, C clockwise. Okay. Now second one, star zigzag star. When there is delta, EMF is always sinusoidal. So actually we don't want this delta zigzag star. There is no use of delta zigzag star. But star zigzag star we can use because of that problem. But delta star, no problem first. But still we are considering this connection also to find what vector group we are getting. That's it. Okay, next. Star zigzag star. Last connection. Second special connection it is star zigzag star. So you draw this, I will give the figure, you tell what vector group it is. Primary three phases, star connected. Secondary star is two equal halves, A by 2, A by 2, B by 2, B by 2, C by 2, C by 2, capital A, B, C, A1, B1, C1, A2, B2, C2. And similarly here A by 2, A by 2, B by 2, B by 2, C by 2. That marking is same as it is previous. Conduct polarity test for each half and mark the polarities. A1, A2, A3, A4. This marking is same for every connection. It is same. Okay. Now primary is a star. Join similar terminals A1, B1, C1 neutral it is. Secondary side, any three similar you can short A1, B1, C1 neutral. Now connect A2 with B4, B2 with C4, C2 with A4. Same as previous zigzag star I taken again. Now which type of vector group it is? Out of 1, 5, 7, 11, we have 4 connections now remaining in the next two connections, delta star and star delta. Out of that 4, any one you will get. Check which connection it is. Try to draw just like previous delta zigzag star. Try to draw this also. This is not 0 degree. Only delta zigzag star. There you will get either 0 or 180. But here you don't get. Right corner delta delta. What is that? I will give this point at the last again. After completion of star zigzag star, I will give about this. Okay, Sahil. First tell me what type of vector group it is. YZ7. Same procedure. Draw the primary star first. Primary side. A1, B1, C1 shorted. A1, A2, A phase. B1, B2, B phase. C1, C2, C phase. Now secondary side delta. Secondary side zigzag star. Primary star, secondary zigzag star. No, same procedure. How to draw secondary zigzag star now? Again, you have to start from neutral. So this is our neutral point. Start from neutral and move towards end. Load is at A3, B3, C3. Source is at A2, B2, C2. Source. Okay. Start from A1 again. First A by 2. First A by 2. That is A1, A2. A1, A2. Then B4, B3. A1, A2, B4, B3. This is the end B3. So A1, A2 draw first. Draw A1, A2. So this is A1 is the neutral. A1, A2 means exactly parallel to primary side. A1, A2. Okay. Draw exact parallel. A1, A2. Next, what is there? A1, A2. Next, B4, B3. A2 connected with B4 and then B3. So from here, this is B4 point itself. B3. Observe B phase on primary now. This is B4. B3 should be like this. B3 here, B4 here. Why? Both parallel. B phase parallel. B1, B3 will coincide. B2, B4 will coincide. So both are in phase, satisfied. Next, this is over. Next, start from B1, B1, B2, C4, C3. So draw first B1, B2. From here, this is B1 parallel to primary B phase. B1, B2. Okay, parallel to primary. B1, B2 parallel to primary B phase. Next, C4, C3. From here, C4, C3. If it is C4, draw parallel to primary. C4, C3. C phase parallel. See, if you have confused, you take a scale and put your scale and as it is draw parallelly. Take a scale in your book and try to draw parallelly. Okay. C parallel. Similarly, start from C1. C1, C2, A4, A3. C1, C2, and from here A4, A3. A4, A3. Okay. C1, C2, A4, A3. Got it? Now all three phases over. Now end terminals just circle. B3, C3, A3. Now resultant we have to draw now. For that we are circling and draw the resultant from the neutral. This is which phase? B it is. And this is which phase? A it is. And this is C phase. This red one is the resultant. A phase, B phase, C phase. And primary anyhow start directly is there. Now take a clock. Take a clock now. Primary capital A pointing toward primary capital A pointing toward. Now secondary small a, if you take both the neutrals coincides each other, then small a you will get exactly at 7. This is 7. Okay. So 7 o'clock connection or 210-degree connection or YZ7 it is. This is YZ7. So star zigzag star is giving what type of vector groups? The transformers delta star and star delta, whatever they given, same vector group it is also given. Okay, so these three transformers, delta star, star delta, and star zigzag star, these three are, I am combining now these three as a one phasor group. These three will give similar groups. Previously delta delta, star star, delta zigzag star, that three connections will give similar vector groups. Okay, now easily you can remember, all these three are similar vector groups. Now totally I will combine all three phase transformers into two groups. I will call it is phasor group 1 and phasor group 2. Okay, so make a note. Completed this. Completed? Make a note. Note. Right. In three-phase transformers, there are two phasor groups. There are two phasor groups. So I will call phasor group 1, phasor group 1. Second, phasor group 2, phasor group 2. Group 1 means the vector groups whatever we are getting 0 degree, 180 degree. So these two I will combine as one group. And group 2 means the 30 degree lagging, 30 degree leading, and 150 degree, 210 degrees. So these four connections I am combining as one group, and this is one group. Now which transformers will give 0 degree, 180 degree? These three transformers: delta delta, star star, delta, zigzag star. Okay, these three transformers are belongs to one group. Next, which transformers will give these vector groups? Delta star, star delta, star zigzag star. These three transformers will give one vector group, that is similar vector groups, 30 degree like 1, 5, 7, 11. These connections possible in these transformers. Okay, now you can easily answer 30 degrees difference. Which connections will give 30 degree difference? These three transformers will give 30 degree difference. 180 degree difference. Which transformers will give? These three transformers will give. Like that, easily you can remember now. For parallel operation also, these 2 points again we will discuss there. In parallel operation, these 2 points again we will discuss. Remember this. Okay. So with these two connections completed in special, and we have open delta and start connection. So tomorrow we will see. Tomorrow from 2 to 7 I will take mostly. Okay, 2 to 7. Tomorrow we will see these two connections, and if time is there, switching transients, and after that parallel operation I will start. Okay, so this is we will see by tomorrow. And day after tomorrow, Monday, auto transformers. So with that our total transformers will be completed. Okay, tomorrow 2 to 7.
Good evening, sir. So 31F. Sir, can you tell the other two connections for Y delta? Like for the Y delta connection, you had given two connections earlier. So can you tell the two other connections?
Are you not getting that two connections?
No, sir. One, I mean, you said that the dot should be with even number terminal. So which one should I take as load?
See, primary star, no need to change, right?
Yes, sir.
So don't change primary star, same. So star, I'm not changing. So for remaining two connections, these are the figures. Those who want, take now the remaining two figures. Third one, fourth one, I will draw the figure, you draw the vector group. Now the third one is like this. Star, delta, primary, second. Small a, B, C. These are the dots. So I'm drawing only connection, you practice the vector group.
Yes, sir.
And A2, A1, B2, B1, C2, C1. Then here, how to connect this? I will take A1, B1, C1 as the load. Here I will connect like this. Okay, I will connect load at A1, B1, C1. Now find which group it is. And for fourth connection, same star. Star is same. I'm not changing primary, only secondary side. So those who want take the figures and try the vector groups A, B, C dots. A1, B1, C1, A2, B2, C2. And in this case, now I will take A2, B2, C2 as the load, and how I will join is like this. Check, all these four are different deltas, not same. A2, B2, C2 load is connected. Now this is one vector group. So try this third and fourth. So those who want take the third and fourth figures.
Sir.
Mm.
Sir, I had a general doubt, sir. The doubt being that in all these vector groups, they give the phase difference between the
Primary line voltage, secondary line voltage.
This is inclusive of all the 180-degree difference that happens between each phase, sir. Like
That
between.
is there, but we are not considering, because anyhow that will be there in every phase. But we are neglecting that only this is we are considering.
So basically, this is after including everything, whatever we are
Yes.
getting phase difference between lines, that we are giving. Sir.
Yes.
I even calculated, sir. So
Yes.
I'm getting what 0 degree, 180 degrees. So I just wanted to confirm.
Okay, good.
So this is inclusive of whatever this takes between phases. So whatever
Yes.
we get at the end, we are considering.
Yes, right.
Sir, is it necessary that the dot terminal should be with the even terminal like A2?
Yes, because we need to follow a standard, no? If you somebody or some other one will take a dot as A1, connection will change.
Okay, sir. So 35 years, sir.
Tell me.
Sir, herein we have done using the vector groups, but even if we don't use vector groups directly, can we see and put it? Is it right?
Directly means if you remember the diagram, no? Suppose delta directly we can say 0, and delta star as you practice 4 groups, if you remember that directly also you can tell without drawing all this. 30
Okay,
degrees.
sir.
Okay.
Thank you, sir.
Hello.
Satya, Anusha.
I have a doubt in this question. Here, in the second connection, star connection, phase voltage is not equal to line voltage. So here our phase diagrams are of phase voltages, right?
See, actually, whatever we are drawing in a clock, these are the line. This is not phase. These are directly line voltages. Okay, never consider this is as phase. In the clock, whatever is there, they are line voltages always.
Okay.
Okay.
Thank you, sir.
Sir.
Tell me, Nil Kumar.
Next problem, sir. 36. Can you please explain this? I did not understand that.
Here directly, these phase voltages we taken exactly both primary, secondary in phase. Okay.
Yes, sir.
A phase and star connection. What is the line voltage? Phase voltage different, no? See, in star connection always this is line voltage. Actually, negative sequence it is.
Okay, sir.
Line voltage lagging phase voltage by 30. But if it is positive sequence, line voltage will lead phase voltage by 30.
30.
So anyhow, phase voltage we are drawing both in phase, primary, secondary first.
Okay. Sir.
According to negative sequence they given, that's why A in anti-clockwise we proceed, B then C. Same as it is for secondary also. But
Okay,
what they are asking in the question, line voltage relations they are asking. Secondary side, this phase voltage itself line voltage. So directly VAB it is. Primary side, line voltage is VAB. What is VAB according to the figure given? VAN minus VBN. That VAB we can drawn here, line.
Okay.
Then comparing this VAB, this VAB. That's it.
Okay, sir.
Okay.
Sir, in vector group, we are finding the degree between prime refer to both primary line voltage only, sir.
Yes, primary line voltage, second, whatever that angles is there now, 30 degree, 150, 210. These are all angle between primary line voltage, secondary line voltage.
Okay, sir.
Okay.
Yes, sir.
Sir, good evening, sir.
Tell me, Jayshree.
Sir, in Delta Star connection, 5 o'clock connection you have given, no, sir, 150 degree lag. Sir, in that I have taken A1B, A1, A2 on the upper side, sir. You have taken in the lower side, no, sir?
This one?
Sir, yes, sir.
What I taken?
Sir,
A1, A2?
you have taken A1, A2 at the lower side, no, sir? I have taken A1, A2 at the upper side, sir.
Why you taken like that?
Sir,
Because if you take A1, A2 here like this, if it is A2, A1, they don't in phase, no? They are not in phase.
sir, no, sir. A1, A2 itself. Oh, okay, okay.
Star, that is you have to consider. Neutral point is A2, no? Here.
Yes, sir.
Maybe you missed it.
Yes, sir. Yes, sir. Okay, sir. Thanks.
Next, Adarsh. Sahil Singh.
Good evening, sir.
Tell Sahil.
Sir, in 36F,
Wait.
secondary is in delta, but sir, we are taking in stars in the phasor diagram.
Phasors. See how to draw delta. These are phasors, not connections directly. Phase voltages we have drawn. Phase voltages in phase. If you observe in our actual connections also, every time we are trying both sides stars only.
Yes, sir.
Even for delta, we are taking internal star.
Okay, this is the internal star.
Yes,
Sir.
yes. Directly we are drawing phasors. Phase voltages in phase, then line voltages we are comparing.
Okay, sir. Thank you, sir.
Good evening, sir.
Yeah, Rameshwari.
Sir, good evening, sir.
Tell me.
Sir, 1 second 35F, sir. Sir, in this second connection, A to A1, from A2, you dragged A1 to the right side, sir. I dragged it to the left side, then I got 7 o'clock, sir.
A2 means how you
A1,
drawn? This
left
is,
side, sir.
A2,
Yes,
A1.
yes,
Then,
sir.
then where you drawn B2? Tell me that point. In the figure, which one are joined? That is in the figure A2, A2, A1. A1 is connected with B2, no?
Yes, sir. From A1, I took right to the B2.
A1, B2, this like this.
Yes, sir.
Then if you draw like this is wrong, no? Sequence. You are getting negative. Okay.
ఓకే సార్ అంటే మనం గీసేటప్పుడు అది నెగటివ్ ఇట్లా
అది
యాంటీ
క్లాక్ వైజ్ లోనే తీసుకోవాలి పాజిటివ్ సీక్వెన్స్ ఫర్ ఆల్ కనెక్షన్స్ అదర్వైజ్ ఇవి ఏది చేంజ్ చేసినా మీకు కనెక్షన్ చేంజ్ అయిపోతుంది
ఓకే సార్ సార్ నెక్స్ట్ స్లైడ్ తీయండి సార్ ఒకసారి నెక్స్ట్ స్లైడ్ 36F సార్ సార్ ఇందులో ఈ సెకండ్ డయాగ్రామ్ రెడ్ ఇంక్ తో గీసారు సార్ విఏబి విసిఏ అది ఎలా వచ్చింది సార్
అంటే ఇది విఏ ఇక్కడ ఏ ఫేజ్ రెండు ప్యారలే కదా ఫిగర్ లో డయాగ్రామ్ లో అంటే మనం డైరెక్ట్లీ ఈ ఫేజ్ ఏ ప్రైమరీ సెకండరీ ఇన్ ఫేజ్ లో డ్రా చేస్తున్నాం ఓకే ఇది విఏనే అనుకో సపోజ్
ఓకే
విఏబి కాదు విఏనే అనుకో అండ్ ఇది విబి కదా అండ్ ఇది విసి కదా విఏ అనేది ఫేజ్ వోల్టేజ్ అండ్ లైన్ వోల్టేజ్ కూడా సేమే కదా డెల్టాలో
అంటే స్టార్ లో ఉన్న ఫేజ్ వోల్టేజ్ కి డెల్టాలో లైన్ వోల్టేజ్ ప్యారలల్ ఉంటున్నాయా సార్
అంటే మనం ఫేజ్ వోల్టేజ్ డ్రా చేస్తున్నాం ఫస్ట్ రెండిట్లో స్టార్ లో డెల్టాలో బట్ ఇన్ డెల్టా వాట్ ఎవర్ ఫేజ్ వోల్టేజ్ యూ డ్రాన్ దట్ ఈస్ ఇట్ సెల్ఫ్ లైన్ వోల్టేజ్
ఇక్కడ డయాగ్రామ్ లో మనకి ప్యారలల్ గా చూపించారు కాబట్టి మనం డైరెక్ట్ గా ప్యారలల్ గా డ్రా చేస్తాం సార్
అది చూపించకపోయినా మీరు డ్రా చేయాల్సిందే ప్యారలల్ ఎందుకంటే ఫేజ్ ఏ వోల్టేజెస్ అనేది ఇన్ ఫేజ్ లోనే ఉంటాయి ఎందుకంటే వాట్ ఈస్ ద ఫ్లక్స్ ఫర్ బోత్ ఫేజెస్ ఫేజ్ ఏ ప్రైమరీ ఫేజ్ ఏ సెకండరీలో సేమ్ ఫ్లక్స్ కదా వెళ్తుంది సో రెండిట్లో ఇన్ బోత్ కేసెస్ వాట్ ఎవర్ ఈఎంఎఫ్ ఇండ్యూస్ బోత్ ఇన్ ఫేజ్ ఆర్ నాట్ అందుకే రెండు ఫేజ్ లో సేమ్ ప్యారలల్ అని డ్రా చేయాలి
Okay, sir. Thank you, sir.
Hello, sir.
Tell me, Dinesh.
Sir, in previous problem, sir.
Hmm.
Sir, in this problem, I draw a phasor A with another direction, sir.
Which direction?
Like, sir, A is in this side. Where is C here? In this side, I draw A. Then, sir, my small a is on 1 o'clock and capital A is 12 o'clock. Means, sir,
That is also no.
A is lags by small a is lags the capital A.
It is leading, na, actually. Small a
Then
leading. That is wrong. Maybe somewhere you did wrong in the connection. Have you checked ABC clockwise are there?
ABC clockwise, yes, sir.
And terminals you marked same A to B to C to.
Yes, sir.
And check internal star getting same ABC or not.
Yes.
Maybe somewhere you wrong it is.
Okay, sir. I will check.
Hello, sir.
Tell me, Pratyush.
Sir, in this question, if in the upper one, if it is delta delta or star star, we are comparing secondaries, no, sir. Delta and V1 and V2, no, sir. They are secondaries.
Oh no. Yes, line voltages.
సార్ ఇప్పుడు అంటే మనం డెల్టాకి వైకి ఖచ్చితంగా 30 degrees ఫేజ్ డిస్ప్లేస్మెంట్ ఉంటుంది కదా సార్
Delta ki
వైకి సార్
30 degrees and directly we cannot say kada because delta star we have two possibilities. 30 degrees is there, plus 30 minus 30 and 150 210. These possibilities are there, no?
ఎస్
Then we have to check now which one it is.
ఓకే సార్ ఓకే సార్
Okay.
సార్ అందర్ డౌట్ సార్ సార్ ఇప్పుడు ఓకే సార్ అర్థమైంది సార్
ఓకే ఇంకా
సార్ ఇప్పుడు అంటే నిన్న చెప్పారు కదా సార్ న్యూట్రల్ షిఫ్టింగ్ కాన్సెప్ట్ అనేది ఇప్పుడు మనం నార్మల్ గా మన డిస్ట్రిబ్యూషన్ నెట్వర్క్ అనేది డిస్ట్రిబ్యూషన్ ట్రాన్స్ఫార్మర్ అనేది డెల్టా వై కనెక్ట్ చేస్తాం కదా సార్ ఇప్పుడు మామూలుగా యూజ్ చేస్తాం కదా సార్ ఇప్పుడు మనకి లోడ్స్ ప్రాక్టికల్ గా అన్బ్యాలెన్స్డ్ కదా సార్ లోడ్ కరెంట్స్ అనేవి
ఆల్వేస్ అన్బ్యాలెన్స్డ్ ఎందుకంటే on every phase suppose there are 3 phases, one phase connected to 4 houses, other phase some 5 houses, other phase some 6 houses, randomly they will connect to that people also.
Yes sir.
Definitely it is unbalanced.
సార్ సో అక్కడ అన్బ్యాలెన్స్ అయినప్పుడు మనం ఆ అన్బ్యాలెన్స్డ్ కాన్సెప్ట్ ని హార్మోనిక్స్ అని తీసుకుని అంటే అక్కడ కూడా న్యూట్రల్ షిఫ్ట్ అవుద్ది కాబట్టి దేర్ విల్ బి అంటే
no అక్కడ unbalanced means fundamental voltages only there, delta star kada emf sinusoidal, no harmonics in that, but magnitude of voltages will be different in 3 phases. That is unbalanced.
అంటే ఈ కాన్సెప్ట్ బట్టి అక్కడ అన్బ్యాలెన్స్ అని చెప్పకూడదా సార్?
There are no harmonics. Unbalance is maybe due to angles, unbalance is maybe due to magnitude of voltages, unbalance is due to harmonics. In different cases unnai kada again unbalance lo.
అవును సార్.
That's why
సార్ ఇప్పుడు మరి ఇప్పుడు అంటే ఇప్పుడు ట్రాన్స్మిషన్ లైన్ లో ఫాల్ట్స్ అవుతుంటాయి కదా సార్, ఎల్జీ ఫాల్ట్స్ అలా, అప్పుడు అక్కడ న్యూట్రల్ కాన్సెప్ట్ యూస్ అంటే న్యూట్రల్ షిఫ్టింగ్ పాయింట్ కాన్సెప్ట్ యూస్ చేసి హెల్దీ ఫేజ్ వోల్టేజ్ అనేవి √3 times ఆఫ్ ఫేజ్ వోల్టేజ్ అవుతాయి అని అంటారు కదా సార్, అంటే వాటి యొక్క వోల్టేజ్ పెరిగిపోద్ది అంటారు కదా సార్.
yes
అక్కడ మరి అక్కడ అన్బ్యాలెన్స్డ్ కదా సార్?
yes అది unbalanced case, faults అని unbalanced case కదా.
ఎస్ సార్, కానీ అక్కడ ఈ కాన్సెప్ట్ బట్టి మనం న్యూట్రల్ అంటే అక్కడ న్యూట్రల్ షిఫ్ట్ అనేది ఈ కాన్సెప్ట్ బట్టి చెప్పం సార్.
ఎస్ రెండు సేమే ఏదైనా, కాకపోతే ఇక్కడ ట్రాన్స్ఫార్మర్ ఓన్లీ డిస్కస్ చేస్తాం, అక్కడ కంప్లీట్ ట్రాన్స్మిషన్ లైన్ అండ్ ట్రాన్స్ఫార్మర్ రెండు డిస్కస్ చేస్తాం.
అంటే సార్ అక్కడ ఫాల్ట్ అయినప్పుడు అంటే అక్కడ థర్డ్ హార్మోనిక్స్ ఏం ప్రొడ్యూస్ అవ్వదు కదా సార్, అంటే ఈ కాన్సెప్ట్ అక్కడ ఎలా
థర్డ్ హార్మోనిక్స్ అంటే మనకి ఆ ఫాల్ట్స్ డిఫరెంట్ ఉన్నాయి కదా, పాజిటివ్ సీక్వెన్స్ కాంపోనెంట్స్, నెగిటివ్, ఆల్ విల్ కమ్ ఇన్ ద ఫాల్ట్ బేస్డ్ ఆన్ ద టైప్ ఆఫ్ ఫాల్ట్, ఎల్జీ ఫాల్ట్, ఎల్ఎల్జీ ఫాల్ట్ ఆర్ ఎల్ఎల్ ఫాల్ట్ ఆర్ LLL ఫాల్ట్, డిఫరెంట్ ఫాల్ట్ కండిషన్ ని బట్టి ఈ జీరో సీక్వెన్స్ డిపెండ్ అవుతాయి థర్డ్ హార్మోనిక్స్.
ఇప్పుడు జీరో సీక్వెన్స్ కాంపోనెంట్ ఉంటే మనం ఆ కాన్సెప్ట్ యూస్ చేయొచ్చు.
yes neutral oscillation.
ఓకే
okay
Sir, in 36 sir. సరే ఇది సెకండరీ సైడ్ ఎట్లా డ్రా చేస్తారు ఒకసారి మళ్ళీ చెప్తారా?
Secondary phases parallel to primary phases. VA, VAN, both parallel. Okay. VB, this is VB. VB, VBC both same. VB parallel to VBN and VC parallel to VCN. But in star line voltage different కాబట్టి దాని వరకు డ్రా చేస్తుంది. But delta లో VA itself VAB both are same.
ఓకే సార్ 39 సార్. సార్ ఇక్కడ కరెంట్స్ ఫుల్ లోడ్ దగ్గర అడిగారు కదా సార్, ఒకవేళ అలా లేకుండా 0.5 లోడ్ అట్లా అడిగితే అప్పుడు ఎట్లా సార్? లోడ్ డిఫరెంట్ లోడ్ దగ్గర
when they given 50% we cannot find this question. ఎందుకంటే whatever the power given is output power which is mechanical power. If they say half load, you should not take half in this. Only for electrical current half అవుతుంది, కానీ మెకానికల్ డిఫరెంట్ అది. అందుకే మనం ఫుల్ లోడ్ కాబట్టి చేయగలం, అదర్ హాఫ్ ఫుల్ లోడ్ అయితే we cannot. Then they should give what is the mechanical power at that half load condition, then we can solve. Same procedure.
Okay. Okay sir. 46 is 45 is sir. సార్ ఇక్కడ పొలారిటీస్ మార్కింగ్ చేశారు కదా సార్, అది ఎలా చేశారు సార్?
సేమ్ ఫస్ట్ డాట్స్ పెట్టండి, డాట్స్ ఇండికేట్ చేయండి ఫస్ట్.
అంటే జస్ట్ మామూలుగా ఫిక్స్డ్ సార్ అట్లే ఉండాలి అని?
అట్లే అంటే మీకు మనం పొలారిటీ టెస్ట్ చేస్తే అది సపోజ్ ఏ సైడ్, సపోజ్ ఈ పార్ట్ ఉంది, దీనికి డాట్ ఎలా వస్తుంది? సో ప్రైమరీ సైడ్ దేర్ ఈస్ సమ్ ప్రైమరీ వైండింగ్, ఏ ఫేజ్, ఇది ఏ బై 2, ఈ రెండింటి ఫస్ట్ పొలారిటీ. మనం పొలారిటీ టెస్ట్ చేస్తే ఇది డాట్ అయింది, సో ఈ దీంట్లో ఏదైనా డాట్ అవ్వచ్చు, సపోజ్ ఇది డాట్ అయింది. సిమిలర్లీ అగైన్ డూ ఫర్ రిమైనింగ్ హాఫ్, అది డాట్ ఇక్కడ వచ్చింది, సో డాట్ మార్క్ చేయాలి. సో randomly we are taking in the figure
అంటే ఇది
dots.
ఇప్పుడు లెన్స్ ల ద్వారా అట్లా చెప్పలేము.
పొలారిటీ టెస్ట్ ఉంది కదా, నో మనకు పొలారిటీ టెస్ట్ ఉంది కదా ప్రొసీజర్, సేమ్ అలానే చేయాలి పొలారిటీ టెస్ట్.
నెక్స్ట్ పేజ్ సార్, ఇక్కడ డెల్టాలో న్యూట్రల్ పాయింట్ నుంచి అన్ని లీవ్ అవుతున్నట్టు తీసుకున్నారు కదా సార్, మామూలుగా కరెంట్స్ అనేవి న్యూట్రల్ పాయింట్
కరెంట్ అనేది ఇది కరెంట్ కాదు, ఇది కరెంట్ కాదు, జస్ట్ ఒక ఇండికేట్ చేయడానికి అలా తీసుకున్నారు. తీసుకోకపోయినా నో నీడ్, జస్ట్ నో నీడ్ జస్ట్ ఒక లైన్ డ్రా చేసి
అదే సార్ డైరెక్షన్ తీసుకుంటే డౌట్ వచ్చింది.
నో డైరెక్షన్ తో మనకి నో రిలేషన్, జస్ట్ అది స్టార్ అంటే అలా క్లాక్ లో అలా ఇండికేట్ చేస్తున్నాం కదా, అందుకని అలా డ్రా చేస్తాం. ఇక్కడ కూడా అలానే తీసుకున్నాం కదా కరెంట్స్.
Sir, Dinesh sir.
Tell Dinesh.
Sir, in my mistake in this problem, sir, in 35, I tell you recently, sir. Sir, can I send the photo
send
on
it.
Telegram, sir, now?
Send.
Sir, I send it.
Sir.
Rakesh.
Sir, in that induction motor problem is there, no sir, just now?
Sir, wait, 1 minute, Dinesh. So your delta is wrong there, because check in delta, you drawn ABC anti-clockwise. A1, A2, then in clockwise only B1, B2 should be there, no?
A1, A2, okay, yes, yes.
That
means,
you did wrong.
Means in upper side B1, B2
yes,
in
yes,
parallel.
Yes.
Okay, sir. Good. Thank you, sir. Thank you, sir.
Okay, right.
Sir.
Rakesh, tell me, Rakesh.
Sir, in that induction motor, my doubt is like induction motor will receive reactive power, no sir? So how to equate in that term, sir? Like if I use 3 into VI sin phi.
No, whatever it is, man, calculations always with active powers only. We don't do reactive power losses or calculation.
Yes, sir. Like we got there 41,444.44. That is reactive power, no sir? Active power.
That is. Calculation is always active power only. Reactive power we never substitute in our efficiency calculation.
Okay, sir. But actually, in practical, input will be given as reactive power to get flux generation.
No. That is, we are giving volt ampere. It will consume reactive power, but useful is what finally torque production, active power only.
Okay. Got it, sir. Thank you.
Okay.
Good evening, sir.
Shravya, tell me.
సార్ ఏ కనెక్షన్ లో అయినా కూడా A1 నుంచి A2 డైరెక్షన్ ఎలా ఉంటుందో ప్రైమరీలో సెకండరీలో కూడా A1 నుంచి A2 డైరెక్షన్ అలానే తీసుకున్నాం కదా సార్. ఎందుకు అలా తీసుకున్నాం? ఏమన్నా స్టాండర్డ్ అది?
A1 నుంచి A2 డైరెక్షన్ అంటే సపోజ్ ఇది A2 A1 ఓకే, డైరెక్షన్ మనం ఏం పెట్టలేదు కదా ఇక్కడ.
అంటే సార్ ఇప్పుడు సెకండరీలో కూడా ఇది కోయిన్సైడ్ అయ్యేలాగా తీసుకున్నాం
అంటే మనం సెకండరీ డ్రా చేసేటప్పుడు ప్యారలల్ గా ఇన్ ఫేజ్ ఉండాలి కదా. సెకండరీ ప్రైమరీ ఈఎంఎఫ్ సెకండరీ ఈఎంఎఫ్ ఇన్ ఫేజ్. సో ఇక్కడ A1 A2 నే పెట్టాలి. సపోజ్ ఇలా డ్రా చేసేసి ఇక్కడ A2 A1 పెడితే ఏమవుతుంది? ఇది ఆపోజిట్ అయిపోయింది. దిస్ ఈజ్ A1, ఇది A2 అనుకోండి, ఇది రివర్స్ కదా. సపోజ్ ఈ 2 లైన్స్ ని కోయిన్సైడ్ చేయండి. ఇక్కడ A1 పెట్టారు, ఇక్కడ A2 పెట్టారు, ఈ రెండు కోయిన్సైడ్ అవ్వట్లేదు, డిఫరెంట్. సో దిస్ ఈజ్ రాంగ్. సో మనం సెకండరీ
ఏంటి సార్? లైన్ వోల్టేజెస్ ఫేజ్ వోల్టేజెస్?
దీస్ ఆర్ లైన్ వోల్టేజెస్. A1 A2 నథింగ్ బట్ A2 itself B1 నో. అంటే మనకి A1 B1 మధ్యలో వోల్టేజ్ వచ్చినట్టే కదా ఇది.
yes sir.
చూడండి ఆ ఫిగర్స్ లో సపోజ్ హియర్ నో డెల్టా. yes చూడండి A2 A1 we are drawing A2 A1 or take previous connection. See here A2 B2 is the line voltage kada.
yes sir.
A2 first we are drawing A2 A1. okay, A2 A1, observe the diagram. A2 A1. Now A2 A1 A1 C2 both are same points kada. A1
Yes,
anna
sir.
C2 anna same point. Now check between A2 C2 what is the voltage. A2 ki C2 ki మధ్యలో voltage ఏమవుతుంది? లైన్ ఆఫ్ ఫేజ్ అది. A2 కి C2 కి ఈ లైన్ కి మధ్యలో వచ్చే వోల్టేజ్ లైన్ వోల్టేజే కదా.
Line voltage.
yes అది లైన్ వోల్టేజెస్. ఇవన్నీ లైన్ వోల్టేజెస్. వాట్ ఎవర్ వి ఆర్ డ్రాయింగ్ ఆల్ లైన్ వోల్టేజెస్.
okay sir.
Good evening, sir.
tell which one.
Sir, in 36 left, sir. Secondary is delta, no, sir. How we are getting that connection as star? Yes, sir.
This is not star. These are phasors. Whether it is in delta also we are drawing internal star or not.
Okay.
Same as it is directly we draw this star here.
Now these are phasor voltages. Sir.
Phasor voltages. Primary phase, secondary phase, both in phase. Like that, phase B in phase, phase C in phase. And then we are drawing line voltages.
But now you told me draw that for line voltages, no, sir.
So here ఈ figures లో మనం డ్రా చేసేది phasors ఇవి.
So we can draw these for both line and phase, sir. These phasor diagrams.
రెండిటికి see suppose ఇది VAB కదా. ఇదే ఫిగర్ లో VBC ఎక్కడ వస్తుందో చెప్పండి. VBC అనేది VBN minus VCN. This is minus VCN. And VBC equal to VBN minus VCN. So if you draw the resultant, you will get VBC here. And VCA ఎక్కడ వస్తుంది? somewhere ఇక్కడ వస్తుంది VCA. VAB VBC VCA ఇది కూడా స్టార్ ఏ ఉంది కదా. ఇవి కూడా లైన్. ఇది లైన్ VAB VBC VCA. This is line voltages. And VA VB VC, these are the phase voltages. Okay. In star, the phasors having different line voltages, different phase voltages. But in delta, the phase voltage line voltage relations are same. Same phasors indicates line.
కానీ డెల్టాలో డెల్టా షేప్ రావాలి కదా సార్. అది ఎలా అని
షేప్ డెల్టా అని కాదు మరి. షేప్ యూ డోంట్ గెట్ డెల్టా. అంటే మనం ఇక్కడ ఫేజర్స్ అలా డ్రా చేసి లాస్ట్ లో మనం స్టార్ లోకి కదా కన్వర్ట్ చేస్తున్నాం అగైన్ టు సే క్లాక్. డెల్టా డైరెక్ట్ గా యూజ్ చేయట్లేదు కదా.
సార్ ఇన్ షార్ట్ సర్క్యూట్ టెస్ట్ హెచ్వి సైడ్ అదేంటి ఐ రేటెడ్ ఇచ్చినా కూడా మన వోల్టేజ్ అనేది 5 to 10% దట్ ఫుల్ వోల్టేజ్ ఉండొద్దు కదా సార్ వి రేటెడ్.
No Suppose any side అది 5 to 10% అది high voltage అయినా low voltage అయినా.
కాకపోతే ఐ రేటెడ్ ఉన్నప్పుడు వోల్టేజ్ కూడా వి రేటెడ్ లో ఉండాలి కదా సార్, అట్లా 5 to 10% ఎలా అవుతుంది?
అది షార్ట్ సర్క్యూట్ కదా. జనరల్లీ మనం లోడ్ కనెక్ట్ చేసినప్పుడు అది రేటెడ్ వోల్టేజ్ అప్లై చేయాలి, రేటెడ్ కరెంట్ రావాలి అంటే. లోడే లేదు కదా, జీరో ఇంపిడెన్స్ కదా, షార్ట్ కదా. షార్ట్ అనేది జీరో రెసిస్టెన్స్ వెరీ లెస్ అయితే what is the magnitude of current for low voltage also? Very low resistance. Then as for small voltage itself high currents flow అవుతాయి. లోడ్ లేదు కదా, లోడ్ ఉంటే మీరు రేటెడ్ వోల్టేజ్ అప్లై చేయాలి, రేటెడ్ కరెంట్.
సార్ ఇన్ పవర్ ట్రాన్స్ఫార్మర్ మనం ఓన్లీ కాపర్ లాసెస్ ని తగ్గిస్తున్నాం అండ్ డిస్ట్రిబ్యూషన్ లో ఓన్లీ ఐరన్ తగ్గిస్తున్నాం, అలా ఎలా సార్? 24 hours రెండు జరుగుతాయి.
ఓకే, మేబీ ఆల్రెడీ నేను ఎవరికో చెప్పినట్టున్నాను ఈ డౌట్. మనకి పవర్ ట్రాన్స్ఫార్మర్ ఆల్రెడీ సైజెస్ ఏంటి, ఆల్రెడీ లార్జ్ సైజ్ కదా ఇవి అన్ని. పవర్ ట్రాన్స్ఫార్మర్స్ అనేది హై రేటింగ్స్, సో రేటింగ్స్ ఎక్కువ కాబట్టి ఆల్రెడీ పవర్ ట్రాన్స్ఫార్మర్ సైజ్ ఈస్ లార్జ్. ఓకే, సో there are both losses 24 hours taking place, iron and copper. Now which one we should take care? Copper. Why? If you take care of iron, means how to reduce iron loss? By increasing size. Already size large kada, inka ekkada size increase chestam danni man. So only the possibility is reducing copper loss. Kani distribution transformers lo manaki 24 hours unde loss edi iron, so danni control chestam.
సార్ ఇక్కడ ఆంపియర్ టర్న్ కి ఆంపియర్ పర్ టర్న్ కి డిఫరెన్స్ ఏంటి సార్?
ఆంపియర్ పర్
టర్న్ అంటే లైక్ కరెంట్ పర్ టర్న్ లాగా
అంతే, సేమ్ I/N.
ఆంపియర్ టర్న్ అంటే ఏంటి సార్?
ఆంపియర్ టర్న్ ఈజ్ MMF కదా, MMF NI, నెంబర్ ఆఫ్ టర్న్స్ అండ్ కరెంట్.
సార్ లోడ్ బ్యాలెన్స్డ్, లోడ్ అన్బ్యాలెన్స్డ్ అంటే ఏంటి సార్?
Load balanced means suppose there is a 3-phase transformer ABC, 3 phases. Suppose there is one load on A phase with a neutral wire, and B phase one load, C phase one load neutral. Balanced means what? All 3 loads should draw same magnitude of current, 10 ampere, 10 ampere, 10 ampere. This is balanced condition. But practically these all the loads will have same loads, capacities? No, definitely ఈ currents are different అయిపోతాయి. Then that is the unbalanced condition. Still under unbalanced we can operate transformer, only particular shell type is best for unbalanced. Okay,
thank you sir.
Sure. Next, Sagar.
Sir, how we are observing internal stars, sir?
How we are
observing internal stars, sir, in zigzag.
In zigzag, that is resultant, no?
In resultant phasor we are observing
see at the terminal what is there here? Terminal B3, so corresponding we take B phase, and whatever the terminal will come at the end, that is the corresponding phase. Okay.
Okay, sir. Sir, 18F, sir.
18. Oh.
Yes, sir. Sir, one of both points.
Which one?
Fourth point, sir.
Fourth point. It provides low reactance path for zero sequence current. So why we are using this tertiary winding here? Previous grounding method is the third harmonic is having low impedance path, because impedance offered by ground and transmission line and all increases, no? So what is the magnitude of I3 there? Less.
Yes, sir.
But by using tertiary winding, less. Low impedance path, no, it is. Impedance is less.
Sir,
Because
in
winding.
tertiary winding also it has a impedance also.
That is there.
In
That
tertiary winding
impedance.
it has a
Only Z3.
okay, sir. Sir, when we are connecting a wrong polarity delta connection, sir, you told that 2E1 voltage will produce, no, sir. How the circulating current will increase, sir?
If resultant fundamental voltage in the loop is 2E, what is the current? 2E1 by that impedance. But if
Yes,
resultant
sir.
EMF 0, what is the circulating current? 0.
Yes, sir.
That's all.
Oh, voltage increasing, so that
Yes,
circulating
current.
current also increasing. Okay, sir. Thank you, sir.
Next.
सर
चल
सर ये डॉट एट इवन पॉइंट्स लेते ना सर अपन डॉट सर वो इसलिए लेते कि अपन ये डॉट मतलब प्राइमरी का डॉट और सेकेंडरी का डॉट एक पैरेलल में आना इसलिए ऐसा लेते क्या सर? अब एक बार वो फिगर निकालो ना सर. अपन एक प्रॉब्लम डेल्टा जिगजैग स्टार और स्टार जिगजैग डेल्टा उसके वेक्टर्स ड्रॉ करें ना सर. इसके इनके नाम्स क्या है सर? वेक्टर ग्रुप्स नेम्स
नेम्स मींस
ये फिगर्स को क्या बोल के बुलाते सर?
वेक्टर्स ओनली वेक्टर ग्रुप वेक्टर डायग्राम्स ऑफ थ्री फेज कनेक्शंस.
ओके ये वेक्टर डायग्राम्स में ये A2 A1 अपने को क्वेश्चन में A2 एक बार बैक पेज जाके फ्रंट पे जाओ. यहाँ पे A2 का डॉट है ना सर. हाँ और यहाँ पे A/2 कहने क्या है कि A2 और A4 का डॉट है. अब नेक्स्ट पेज जाओ सर. वो A2 डॉट और ये यहाँ पे A4 डॉट एक ही आना बोल. इसका मतलब डॉट सेम आना लेकिन इवन ऑड की अपने को परवाह नहीं है ना सर. डॉट से अपन वो नोटेशन सिर्फ अपन रख लिए.
ओनली डॉट शुड कोइंसाइड अनडॉट शुड कोइंसाइड. दैट इज ओनली इन फेज कांसेप्ट ना.
मैं वही चीज कर रहा था सर लेकिन नंबर्स अलग लिया मैं A1 A2 A3 A4 इसीलिए.
डोंट दैट्स व्हाई स्टैंडर्ड वी शुड फॉलो.
ओके सर नाउ आई विल फॉलो दिस वन. ओके सर. सर वन मोर सर. आप ये ABC कभी भी क्लॉकवाइज में आना बोल के बोले ना सर.
दैट इज पॉजिटिव सीक्वेंस वी अप्लाई ना सोर्स ऑलवेज. दैट्स व्हाई वी टेक पॉजिटिव सीक्वेंस ABC.
और ये वेक्टर डायग्राम ड्रॉ करते जब ऐसी आना ना सर. ABC
क्लॉकवाइज ABC शुड बी देयर.
अगर क्वेश्चन में नेगेटिव सीक्वेंस अप्लाई बोले तो
टेक ABC नेगेटिव ABC एंटी क्लॉकवाइज.
और डेल्टा भी एक बार बाजू डेल्टा भी डालो ना सर. डेल्टा स्मॉल डेल्टा एक डालो ट्रायंगल. अब यहाँ पे पॉजिटिव ABC बोल तो अपन A राइट साइड
एनीवेयर.
ओके अकॉर्डिंग. ओके सर थैंक यू सर. डन सर.
ओके
सर
अब्दुल रहमान टेल.
सर ये प्रीवियस प्रॉब्लम एक है सर वो थोड़ा डाउट हो रहा था.
कौन सा?
ये प्रीवियस क्लास में हुआ ये क्या है सर? ए नॉर्मल 2 वाइंडिंग डेल्टा डेल्टा ट्रांसफार्मर इन विच the terminals x1 and x2 of the transformer 2 are interchanged by mistake भाई ना सर.
yes
जी सर वो थोड़ा बता सकते हैं सर वो 2 ही कैसा आया थी?
सर मेरा भी वही था सर. नहीं आ रहा था.
नहीं आता है वो. where it is here it is not there no I think.
ऐसा ये प्रीवियस क्लास का शायद सर
2 days पहले का क्लास है सर.
okay so here take delta. How we connect delta opposite polarities? We joined always. Okay. Now take anywhere ABC. A, B, C. Now this is our dotted polarity. Okay. Additivities. Now in each phase we have EMF. E1 at an angle 0, E1 at an angle minus 120. E1 at an angle minus 240. This is under balanced three-phase balanced voltages in delta. Then if you take the sum of these three voltages, maybe it is even additive. You don't get any current inside the circulating currents. You don't get any current here. Sum of the voltages is what? Sum E1 at an angle 0 plus E1 at an angle minus 120 plus E1 at an angle minus 240. If you take this sum in the calculator, you will get 0. That is balanced.
Fundamental.
That is balanced means sum should be 0. But if by mistake any one phase polarity interchange, suppose actual dot is here but this dot I will remove and I will place here. Now if you take KVL again, E1 at an angle 0 as it is, but ये कैसे connect हुआ B से? Negative है ना? So next here E1 at an angle 0 minus आ जाएगा. Previously additive, but now dot undot is there. Minus minus. Negative na it is. Subtraction polarity. Then E1 at an angle minus 120. Previously here plus E1 at an angle minus 240, but check plus is connected with plus. ये भी क्या हो जाएगा? Negative polarity हो गया. So this is also minus E1 at an angle minus 240. अब इसे ऐड करके चेक करना एक बार. Same calculators. You will get 2E1.
सर एक बात सर, आप डॉट अनडॉटेड ऐसा आप क्लियर अब एक सिंपल में मालूम होने के लिए ऐसा बोलते हैं. फॉर एग्जांपल क्वेश्चन में कभी कभी डॉटेड अनडॉटेड पोलैरिटीज नहीं दिए समझ लो सर, उस टाइम पे कैसा हम आइडेंटिफाई करके कैसा हमें सॉल्व करना पड़ता है?
Then you have to assume, suppose actual delta you should know we will connect with opposite polarities always, that is balanced. You should know that point. Now directly they said A, B, C, one of the phase winding suddenly reversed. Now you should write here your own polarities. Then you should tell the sum will be 2E1 directly. Without, if they don't give also you should tell.
Okay. Sir, और एक प्रॉब्लम है सर, क्या है तो यूजिंग पावर बैलेंस इक्वेशन में आप एक फार्मूला बोले ना सर, √3 VL at rate of I'm sorry at an angle plus or minus 5 वैसा up to so on fundamental third harmonic up to so on, उसमें प्लस पर
लीडिंग माइनस पर लैगिंग
माइनस पर लैगिंग का बोले था.
इसमें बोला मैं अभी इधर नहीं बोला ना.
नहीं मेरा दोस्त का है सर, ये नोट लिया था मैं प्रैक्टिस करने लिया तो थोड़ा कंफ्यूज आ था.
ओके
जी.
तो
इसमें क्या है,
वो ऑलरेडी सुना था क्या?
हाँ वो सुना था सर.
इस बैच में
नहीं मालूम सर, मैं नहीं मालूम, लेकिन उसका नोट्स लिया था मैं, कौन से बैच में एग्जैक्ट नहीं मालूम.
ओके ओके.
व्हिच इज क्वाइट ऑपोजिट इन वोल्टेज रेगुलेशन. कि मतलब वोल्टेज रेगुलेशन में प्लस पर लैगिंग ले लेते हैं.
वो इक्वेशन में प्लस पर लैगिंग माइनस पर लीडिंग भी यूज. यहाँ ये क्या है, एंगल है ना, पावर फैक्टर का एंगल.
हाँ.
करंट एट एन एंगल +5 मींस करंट क्या कर रहा है, वोल्टेज से लीड कर रहा है. सपोज वोल्टेज V, करंट लीड कर रहा है, इसे हम प्लस से इंडिकेट करते हैं. I at an angle +5 means current leading voltage by some angle 5. Now what is I at an angle -5 means current lagging voltage by some angle 5. Lagging power factor बोलते हैं.
अच्छा सर, ये पूरा सॉल्व करने के बाद एक सॉल्यूशन आता ना सर, फॉर एग्जांपल x एम्पियर्स एट द रेट ऑफ 50 डिग्रीज आया समझ लो सर.
8 amps at an angle -50.
नहीं फॉर एग्जांपल ये नहीं, कौन सा x एम्पियर्स एट एन एंगल -50 डिग्रीज.
हां,
तब हमें आंसर में ऑप्शन से क्या सेलेक्ट करना है सर?
सेम वही लैगिंग. सपोज cos 50 लैगिंग, व्हाट इज cos 50 वैल्यू कैलकुलेट करना.
हां ठीक है.
So they may give lagging here, that is answer.
अच्छा,
whatever that value
माइनस है इसलिए लैगिंग कर सकते
lagging.
हैं. हाँ सर, और एक है सर, क्या है, हाँ, thickness of lamination is inversely proportional to frequency.
That is WE क्या है इक्वेशन, K BM² F² T² है ना
जी,
into volume is there. So ये सब अगर constant, suppose K constant, density भी given constant, volume भी given constant, then to maintain the same eddy current loss, so यहाँ frequency FT² ना equal to constant, then frequency क्या बन जाएगा, inversely proportional to thickness of lamination. अगर frequency increase हुआ तो you can reduce thickness. Particularly in induction motor में ये use करते हैं. Induction motor में stator is having high frequency 50 Hz F, but rotor frequency is what there, SF, that is 2 Hz 1 Hz will be there, very low. So as frequency is very low, you can increase the thickness of lamination, no problem.
अच्छा सर, आप इक्वेशन के जरिए बोलते हैं, लेकिन मेरे को थोड़ा मैं एक्सप्लेन कर सकते हैं सर कि वो तो थिकनेस कितना कम हो तो उतना एडी करंट लॉसेस कम होता, एडी करंट लॉसेस कम हो तो उतना एफिशिएंसी बढ़ता। लेकिन ये कैसा फ्रीक्वेंसी को रिलेट करता है बोल सकते सर ऐसा? तो आप ये रिलेशन के हिसाब से
अगर थिकनेस ज्यादा है ना पहले
जी,
देन फ्रीक्वेंसी क्या होना चाहिए, कम होना चाहिए। अगर थिकनेस इज मोर, देयर इज मोर एरिया ना टू सर्कुलेट करंट,
हाँ ओके,
then frequency should be less. Suppose if frequency less, then eddy current loss is less only, because frequency means what? Current circulation will increase, positive negative positive negative positive negative. If frequency increase as thickness is more, you will get more eddy current loss.
thickness is more eddy current loss, हाँ okay fine, हाँ
then you have to reduce frequency or you have to reduce thickness.
सर ये समझा नहीं है सर, ये थोड़ा फिर से बोलो एक बार।
फ्रीक्वेंसी ज्यादा है
जी,
अगर थिकनेस भी ज्यादा है, अब लॉस क्या होगा? इंक्रीज हो जाएगा ना, बिकॉज मोर थिकनेस मींस मोर एरिया। देन अब क्या करना है, अगर लॉस को रिड्यूस करने के लिए थिकनेस को कम कर देना। अगर थिकनेस को कम करने से सरफेस एरिया कम हो जाएगा, वो जो सर्कुलेट हो रहा है उसका पाथ भी कम हो जाएगा, तब लॉस भी रिड्यूस हो जाएगा।
वो फ्रीक्वेंसी कैसे रिलेट करता है सर, वो मालूम नहीं है।
फ्रीक्वेंसी 50 साइकिल्स पर सेकंड, 2 साइकिल्स पर सेकंड, 1 सेकंड में 50 टाइम्स ये चेंजिंग पॉजिटिव नेगेटिव, मगर 1 सेकंड में 2 टाइम्स ओनली पॉजिटिव नेगेटिव स्लोली, लॉस कम है ना उसका।
अच्छा 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 ओ सर और एक सर ये तो क्या है, हाँ और क्या कहते सर, प्राइमरी करंट I1 इज इक्वल टू kVA by E1 करते ना सर?
I1 kVA वोल्ट एम्पियर by E1,
I2 इक्वल टू kVA by E2,
वोल्ट एम्पियर by E2।
शॉर्ट सर्किट करंट इक्वल टू kVA by जो HV वोल्टेज अप्लाई कर रहे तो करते ना सर शॉर्ट सर्किट टेस्ट है,
वोल्ट एम्पियर रेटिंग by HV वोल्टेज,
जो HV वोल्टेज।
ये दो सेम है, यहाँ सेम ही है। रेटेड करंट ISC भी रेटेड करंट बोलते हैं ना। ISC क्या है? शॉर्ट सर्किट नहीं है, वो शॉर्ट रेटेड करंट अंडर शॉर्ट सर्किट।
हाँ ओके सर,
वो भी सेम इक्वेशन बोलते हैं।
ये दो भी एक ही है सर, I1 इक्वल टू
सेम I1 और ISC, सपोज HV साइड I1, ISC भी सेम, वो दो भी एक ही है।
ठीक है, तो वोल्टेज अलग होते हैं ना सर, वोल्टेज आई एम सॉरी, या इंड्यूस्ड EMF अलग रहता फिर भी, या HV अलग रहता ना सर। फॉर एग्जांपल मैं एक कंसीडर करूं सर, क्वेश्चन इज इक्वल टू 400 by 230 वोल्ट समझ लो सर,
ओके
हाँ 200 वोल्ट, तब I1 है तो I1 इज
सपोज
ओके 1 kVA ले लो सर, 1 kVA 2
kVA 1000, देन I1 इज व्हाट 1000 by 400,
400
हाँ इसे ही हम ISC बोलते हैं, शॉर्ट सर्किट रेटेड करंट अंडर शॉर्ट सर्किट, बिकॉज हाई वोल्टेज पे ही कैलकुलेट करते हैं ना हम। both are same, and 10 by 4 2.5 ampere rated current or full load current, both are
वो रेटिंग 200 by 400 वोल्ट रख लेते सर?
जो भी है, अगर 200 by 400 है,
हाँ
इसका प्राइमरी करंट क्या होता? 1000 by 200
होती है,
ये 5 एम्पियर। सेकेंडरी करंट क्या होता? 1000 by 400 2.5 आ जाएगा। अगर वेर वी डू शॉर्ट सर्किट टेस्ट हाई वोल्टेज से 1000 by 400 2.5 ऑन।
हाँ फिर ये इक्वल नहीं हुआ ना सर, ISC इक्वल टू
ISC मींस ISC रिलेटेड विद ऑलवेज HV, जो भी है प्राइमरी भी है और LV भी है, HV भी है, प्राइमरी भी है, HV भी है। ISC रिलेटेड विद हाई वोल्टेज वाइंडिंग। I1 I2 directly we are calculating primary secondary individual calculation I1 I2, मगर ISC क्या है? always related to high voltage side।
हाँ सर, फॉर एग्जांपल क्वेश्चन में हमें रेटेड करंट फाइंड आउट करना था तो kVA by
voltage only।
कौन सी वोल्टेज सर?
which rated current they are asking, primary side or secondary side, वो चेक करना।
नहीं सर, ये क्वेश्चन है सर, आउटपुट पावर 14.96 किलोवाट्स at the rate of 220 volts at 0.8।
their load is connected to LV side now, 220।
हाँ
that's why current we will calculate with respect to secondary side, I2 we calculate।
फॉर एग्जांपल ये 220 वोल्ट्स मेंशन नहीं करे सर, उस टाइम पे कितना वोल्टेज?
load they will say no, load is suppose primary they given some voltage, high voltage, secondary side load is there, if they don't mention 220 also we take secondary only load।
अब वो रेटेड करंट नहीं होती ना सर?
that depends on output power, suppose they give an output from 14.96 kilowatt. So from there we will calculate what is the current by using VI cos kilowatts है ना ये.
हाँ सर.
That's right.
ये थोड़ा समझ नहीं.
प्रैक्टिस करने से आ जाएगा. नो नीड टू फियर.
ठीक है सर, करूंगा सर. अगर डाउट है तो आप मैं फिर भी
ओके श्योर.
थैंक यू सर.
सर सर ये अपन क्लॉक डायग्राम्स ड्रॉ करते जब हवर हैंड क्या कि एलवी, मिनट्स हैंड क्या कि एचवी बोल के अपन एज्यूम कर लिए ना सर स्टार्टिंग में, और वो प्राइमरी सेकेंडरी बोल के भी एज्यूम कर लिए. तो अपने को अब प्राइमरी साइड एलवी, सेकेंडरी साइड एचवी है, तो भी सेम नॉर्मल वही प्रोसीजर है ना, कुछ अलग है?
नहीं, सेम प्रोसीजर.
स्टेप अप ट्रांसफार्मर में
अगर जो भी दिए यू कंसीडर एचवी इज योर प्राइमरी.
आई एम कंसीडरिंग एलवी इज माय प्राइमरी सर. इफ इन केस अपन
okay then considered HV will be secondary sir. Then LV you take minute hand only, HV you take hour hand only.
Okay it
same as it is, but only we are following one condition for all connection. This confusion नहीं होना है ना.
सर तो अगर HV जो है उसको बड़ा कांटा लेना है बस उतना ही.
Yes, that's it.
Okay, thank you sir.
హలో సార్. ఇప్పుడు అన్బ్యాలెన్స్డ్ కరెంట్స్ వల్ల మనకి ఫ్లక్స్ కూడా అన్బ్యాలెన్స్ అవుద్ది కదా సార్. అంటే మీరు షెల్ టైప్ లో అన్బ్యాలెన్స్డ్, ఇప్పుడు షెల్ టైప్ లో ఫ్లో అయితే అంటే ఆ ఎంప్టీ లిమ్స్ లో ఫ్లో అయితే ఎలా సార్? ఈఎంఎఫ్ కూడా మనకి అంటే మనకి తిరిగి మళ్ళీ ఈఎంఎఫ్ సైన్సోయిడ్ అవ్వడానికి అది ఉపయోగపడుతుంది కదా సార్.
అన్బ్యాలెన్స్ అంటే ఫ్లక్స్ అనేది సైనూసాయిడల్. ఫ్లక్స్ లో మనకి హార్మోనిక్స్ లేదు, unbalance అయింది. whatever flux produced in all the limbs is different flux producing, for example.
Yes sir.
different flux produced in 3 limbs.
Okay.
different flux. సో ఈ ఫ్లక్స్ అంతా ఏమవుతుంది? ఇప్పుడు సపోజ్ ఇక్కడ సమ్ అయింది, రిజల్టెంట్ ఫ్లక్స్ యాక్చువల్లీ 0 అవ్వాలి. అదే కదా మనకి స్టేబుల్, అది ఏమంటాం బ్యాలెన్స్డ్. సమ్ ఆఫ్ ద ఫ్లక్స్ విల్ బి 0. but 0 అవ్వట్లేదు అంటే unbalanced. then the whatever remaining flux is there, it will take the path through empty limbs లో వచ్చినా కూడా మీకు ఈ ఇంటర్నల్ గా వచ్చేది సేమ్ అదే వస్తుంది. అండ్ వాట్ ఎవర్ ఈస్ ప్రొడ్యూస్ అదే వస్తూ ఉంటుంది. అంటే అది బ్యాలెన్స్డ్ కండిషన్ లోనే ఆపరేట్ అవుతుంది ఎనీ హౌ ఫైనల్లీ. కానీ మీకు కోర్ టైప్ లో అలా అవ్వదు కదా. ఇది కోర్ టైప్ లో ఈ వచ్చిన ఫ్లక్స్ బయటికి వెళ్ళిపోవాల్సింది, ఎందుకంటే నో రిటర్న్ పాత్. అప్పుడు బయటికి వెళ్ళిపోతే ఏమవుతుంది? ఇక్కడ బ్యాలెన్స్ అది మళ్ళీ రీచ్ అవ్వదు కదా అదే ఫేజ్ కి వచ్చి.
అవును సార్.
త్రూ ఎయిర్ వెళ్ళిపోతుంది. సో వన్స్ ఇట్ కమ్స్ ఇన్ ఎయిర్, ఆ ఫ్లక్స్ అనేది ఆల్మోస్ట్ రెడ్యూస్ అయిపోతుంది. కానీ రిటర్న్ మనకి అది సేమ్ రాదు, కంటిన్యూ ఫ్లో రాదు. అప్పుడు ఇది అన్బ్యాలెన్స్డ్ వోల్టేజెస్ కింద కన్వర్ట్ అవుతుంది. ఈ వోల్టేజెస్ ఇండ్యూస్ ఇన్ వైండింగ్స్ ఆల్సో బికమ్ డిఫరెంట్. కానీ ఇక్కడ వచ్చేది మాత్రం ఏ ఈఎంఎఫ్ అయితే ఇండ్యూస్ అయిందో అదే వస్తూ ఉంటుంది, సేమ్ వోల్టేజెస్.
అంటే ఇప్పుడు మనకి ఆ అన్బ్యాలెన్స్డ్ ఫ్లక్సెస్ ప్రొడ్యూస్ అయినా కోర్ లోనే అది ఎంప్టీ లిమ్స్ లో అన్బ్యాలెన్స్ ఫ్లో
ఎంటీ లోకి వెళ్ళిపోతుంది. అండ్ మళ్ళీ ఫేజ్ లోకి వచ్చేటప్పుడు ఏదైతే బయటికి వెళ్ళిందో అదే లోపలికి వస్తుంది.
అది ముందలా పార్ట్ డివైడ్ అయిపోతుంది అంతేనా సార్? ఆ కరెంట్ అది కోర్ టైప్ లో అయితే ఆ పార్ట్ డివైడ్ అవ్వదు, కానీ ఫ్లక్స్ పోతుంది కదా సార్. అక్కడ కూడా బ్యాలెన్స్ కదా సార్ వచ్చేస్తుంది.
కానీ ఫ్లక్స్ బయటికి వెళ్తుంది కదా, కోర్ లోకి రావట్లేదు కదా. రిటర్న్ పాత్ కి ఎంటీ లిమ్ లేదు కదా దీంట్లో.
అవును సార్, ఫ్లక్స్ బయటికి వెళ్ళిపోతుంది.
ఫ్లక్స్ బయటికి అంటే
ఓకే సార్. అంటే ఇక్కడ ఫండమెంటల్ అన్బ్యాలెన్స్ అయితే ఓకే సార్, దానికి బయటికి. ఓకే సార్, థ్యాంక్ యూ సార్.
Sir, we consider our hand as primary, sir.
Our hand is yes, HV. So we are considering all primary connections is high voltage, secondary LV voltage. High voltage is always minute hand. High voltage is the minute hand. LV is the short hand, hour hand. This is hour hand. This is minute hand. The long one is HV phasor. Short one is LV phasor.
The primary ante minute hand sir ippudu.
Yes, minute hand. అదే కదా క్యాపిటల్ ఏ తీసుకుంటాం కదా అన్నిట్లో. క్లాక్ అనేది ఎలా చెప్తాం? క్లాక్ ఈ మినిట్ హ్యాండ్ 12 దగ్గర ఉండాలి, షార్ట్ హ్యాండ్ అనేది డిఫరెంట్ డీస్ కి మూవ్ అవుతూ ఉంటుంది. అదే కదా క్లాక్ అనేది.
ఎస్ సార్.
దట్స్ వై.
థ్యాంక్ యూ సార్.
Okay. Tomorrow we meet same 2 to 7.